Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? All right, let's start this on Discord. Yo, what's today? Today is National Football Day. American football, right? Not that European stuff. I know. It is interesting that football is called football, but they never really... You don't really use your feet to, like, connect with the ball in American football. What's up, Jarkeezy? What's up, Blenatrix? Yeah, I was, my favorite football team are the Eagles. I've been adopted. My roommates are not my roommates. Sorry, my neighbors are from Philly, and they're very heavy Eagles fans. So I went as the mascot for Halloween this year. This is me, like a big Eagles costume. I had to have the gold chain, of course. It's kind of funny. Linear algebra exam. All right, Jarkeez. Good luck with it, dude. Eagles with an actual eagle. Yeah, it is, dude. Yesterday took a whole huge toll on me. Did you have a long exam, Lineatrix? What happened yesterday, dude? What was cracking? Damn, Equity on the rip, dude. Good job, Equity. You probably know that my streams get slammed with questions now. Which, I have some cool coding stuff. I was vibe coding today to maybe alleviate some of that, or at least like help out when I'm not here. Because you guys have been doing a great job, by the way. I really appreciate, especially Clickbait. Clickbait's been on a fucking roll. We have, right, the whole thread here, and if you go to like unsolved problems, you can see that. So Avish, for instance, submitted a couple, and Clickbait just went in last night, and was just like, hey, I'm just gonna write up the solutions for these. That's really cool, Clickbait. I appreciate that. So yeah, we do have an awesome like team of other, I say, actual educators who can help with these questions. This is cool. Ooh, a Laplace transform, and then it looks like Zach did it during his stream. Wow, there we go. Teamwork.
That's dope.
Yeah, that's great. Nice. See, I love that. Yeah. So yeah, I'm very happy that we have, again, other friends who have either their own streams or they just have a passion for teaching and solving problems. So when we, can't get to all the problems in a stream, that someone else can at least help. I imagine, though, that's eventually going to become a scaling issue, though. I know that as the stream gets bigger and we start reaching more and more people, I'm eventually going to run out of friends. Unfortunately, yeah, there's a limit on the number of friends I can have. So while I would love to prioritize having real humans answer everything, I'm foreseeing a point where we start having more than like a couple. It's like dozens, if not hundreds, of unanswered questions. And I'm building a bot to leverage. We have a pretty nice sponsorship with Microsoft. They give like a cushy $2,000 a year in Azure credits to nonprofits, and I applied for it and I got it. So I have a bunch of credit that I can use with Microsoft Azure. Is like Amazon AWS. It's a all-in-one cloud hosting fucking machine. And also Azure, Microsoft happens to own a significant stake in ChatGPT. So they also give us ChatGPT API keys, which means I can run even the crazy ones. I can run GPT-5 Pro, which usually you need a $200 a month account to run, but I have credits for it. So I'm thinking about coming up with a bot that if something doesn't get solved in our Discord after a couple days, that we just start, using our sponsorship thing from Microsoft to just have the best version of AI try to tackle it, to at least show what AI thinks the solution is, and then you can learn from it, and you can also question it. And the great thing about it being already in the forum format is that it opens up a thread for discussion. So after a couple days, if I can get this to work, it was a fucking headache today, even just getting the deployment to work on Azure, but I have the start of something, and I hope to maybe announce it in the next week or so. What's up, Equity? Clickbait, we're just talking about you. Talking about how awesome you are for answering those questions. On your own accord, I really appreciate that. ChatGPT is good enough. Yeah, especially if I use ChatGPT 5 Pro, it's like PhD level. It's ridiculous how smart it is. And again, AI fucks up too. Totally cool. I'm just saying, if someone hasn't answered your question for a couple days, I don't want to leave you out, in a lurch, in the silence, being like, hey man. And I know a lot of students don't have the $20 a month to even get just the premium ChatGPT. I'm talking about leveraging the $200 a month version of ChatGPT as kind of an added bonus to, if no one answers your question in a couple days, I'll just fucking the sickest AI on it, and you can at least see what it does. And I think this is actually a really cool thing to be able to do, is to view what AI is doing and understand its process and then question it. I mean, I do that all the time here on the stream. Sometimes if we get stuck at a certain point, or I want to double check my work, I'll throw it at AI and be like, hey AI, how would you do it? And I can see its methods. Sometimes that unlocks pathways that I didn't think about in the first place, and so I'm like, oh wait, that's a cool way to solve it. Oh, we could do it this way. Or sometimes AI does the wrong thing, and I think it's also a very strong indicator that you understand the subject if you can, be critical about how another approach is trying to do it. So, yeah. I'm a big AI supporter. I know Zach hates AI. I think AI is very cool. I think like anything, it's a tool. There's responsible use for it, and so this is one of the ways I think I'm going to try to use it. Okay, great. We already got 3 questions up, so we're going to start them soon. Oh, other announcement. We hit 10K on YouTube, which is dope.
That's dope.
So tomorrow, Thursday, to celebrate, I'm going to do a 10-hour stream. So 10 hours for 10K. So that'll start at our normal time, which will be 4 o'clock Pacific, but I'm going to go until 2 o'clock in the morning Pacific. So if you want to come hang out, I know there will be no shortage of questions, because even yesterday's stream, which I extended out to 4 hours, I still had like 13 questions left in the queue I hadn't even gotten to. So we're gonna... Thanks, Equity. We're just gonna burn through a lot of stuff tomorrow. and I'm gonna like stress test my system because I do want to do a 24-hour stream. I'm already talking to like some other sponsors and companies about, because I don't think anyone's done like a subathon 24-hour thing for tutoring. So I want to see if we can do it. Yeah, you're new to using AI in the way you just described, and it's been very helpful. Yeah, AI is awesome. You know what it is? And I know nowadays it's hard to make friends. We feel more lonely, isolated. I mean, hopefully, this is a solution kind of to some of that. But I know COVID also messed up a lot of social development for students, and so there's almost like a natural anxiety to like putting yourself out there and making friends. But those friends are what are critical, or at least were critical for me getting through undergrad and grad school. I always needed someone to just bounce ideas off and be like, hey man, am I doing this the right way? Or how did you do it? But I know not everyone has that. Sometimes you're not as extroverted, or again, you're in a classroom where everyone's being so focused on their grades that they don't want to help you. I hate that. It's usually curved classes where that happens. So AI is like another friend. That again, is your friend right all the time, 100% of the time? No. But it's at least someone else to talk to, right? So I think that's where AI can be very useful as like another like pal to bounce ideas off while you're doing questions, and then be critical of the AI. The AI is not perfect. Better grab all the coffee if you're willing to do the 24-hour. I'm probably gonna grab some Adderall, honestly, if that happens. Not that I condone drug use, but whatever. Okay, cool. All right, we already got 3 questions in the queue, so let's head over to the stream and help you guys out. All right, welcome everyone's Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you with math, homework, science, homework. All sorts of fun things. First question of the day comes from Equity. Equity, this is so much nicer, bro. What? I thought you were doing discrete mathematics, and now you just want factoring questions? I'm so happy about these. These look amazing. What happened to the really hard like group theory questions? Where did those go? Where are those? Okay. Ba, 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 da, da. That was just one unit? Man, that was a tough-ass fucking unit. I'll tell you what, dude, what? You were asking some very difficult questions that I'd never even seen. I thought you had definitely, like, surpassed me in terms of, skills. I was like, oh, man, dude, Equity's gone to greater places than I've ever gone. But, yeah, okay. So, whenever you're trying to factor trig functions and stuff, I think the best way is to make sure they're all the same trig function. We agree with that? So there are 2 big identities you're going to use for this, which is, what's up, DMs? Sine squared x plus cosine squared x is equal to 1, and 1 plus tangent squared of x is equal to secant squared of x. Yes, good job, Lineatrix. Yeah, exactly.
Bing bong.
Secant squared of x, yeah. These are all very useful, very important. So, yeah. In this case, for instance, I have cosines and I have sines. I only want one of them. So, I can rewrite this sine squared as is equal to 1 minus cosine squared of x. So, let's just do that. Well, no, I'll show you. So, in this case, now we're going to have 5 minus 4 cosine of x, and then minus, and then this is going to be 1 minus cosine squared x. Okay. Which I can then rearrange a little bit because the minuses are going to pass over and stuff, right? So then I have cosine squared x minus 4 cosine x plus 4. And then, okay, I guess we're not going to say equal to 0, right? We're just factoring. So this is an expression. It's an expression, technically, right? It's not exactly a... It's not an equation. We're not solving. Okay. Cool. So once we have that... one second, let me make sure. I need TikTok chat to work today. Please work. You just don't want to work today. Let's keep this. It's not loading. This is a quadratic, right? Do you see how I have something squared, something to the first power, and something to the 0th power? In this case, we're gonna say, okay, here, let me put this a little bit further down so I can have some room for it. So in this case, I'm gonna say, okay, let u equal cosine of x, then u squared is equal to cosine squared x, and now I can replace this with u minus u squared minus 4u plus 4. And I guess to factor, oh, interesting. What multiplies to 4 but adds up to -4? Ooh, that's -2 and -2. Nice. Good job, Lineatrix. Yep, exactly. So this becomes u minus 2 times u minus 2, which is u minus 2 squared. All right. But then u is equal to cosine of x. So I end up getting cosine of x minus 2 times cosine of x minus 2. Interestingly enough, right, this doesn't have any zeros because there's no way cosine of x can equal 2. Right? So I mean, this is factored technically, but this will never equal 0. It's impossible. No, it just can't happen. Do you understand why that is? Equity? Yeah, okay, cool. Anyways, that's it factored. Let's see another one that's maybe a little trickier. Hypotenuse is the biggest side. Yeah, exactly. Okay. This one, weird. Well, I guess you got to call the cosine squared equal to 1 minus sine squared. And then here, I'll do one of the tangent ones, and then I'll do one of the other ones. All right, so this one we got. This is a double u sub. It's actually kind of fun. All right, I'm gonna write. I think I can write cosine squared as 1 minus sine squared, right? So sine to the 4th x plus 2, 1 minus sine squared x minus 1. So then you get sine to the 4th x minus 2 sine squared x plus 1, right? You could express everything in terms of cosines. Yeah, you could have done that for this as well, but then you'd have to do another sub, which I don't want to do right now. So, now what I say is u is equal to sine squared of x. And then u squared is equal to sine to the 4th of x. Anytime you see the powers going like 4, 2, and then this is technically like sine to the 0 of x. Or, for instance, like 6, 3, or 8, 4. Just make u equal to whatever this one is. And then you're left with u minus 2u squared plus 1. This is easy, right? This is minus 1 minus 1. So you get u minus 1 squared. But u is sine squared x. Oh, this is very cool. So you get sine squared x minus 1 squared. Which, Isn't this just cosine squared? Because then there's another squaring on it, right? So this is the same thing as negative 1 minus sine squared x. Squared. And then 1 minus sine squared x is just cosine squared x. So you have negative cosine squared x squared, but then the squaring will get rid of the negative. And so you just get cosine to the 4th of x. Oh, wow, okay. I guess that's... I mean, this is technically factored, but then this is also, I think, what the factor just eventually becomes, right? And you just set this equal to 0. Pretty cool. Okay, and then let's see maybe one of the other harder ones that you had. It's the same strat, by the way, for secant. You want to turn secant squared into 1 plus tangent squared here, so that you have just tangents. This one, this is another identity you have to know, which is I think that 1 plus cotangent squared is equal to cosecant squared x. Is that right? I think that is.
Hello.
Yo, what's going on, Ram?
Good. I was teaching all day long, and I was trying to watch Penn Center's.
Oh, what was he doing today? Did he have a stream today with Collar Cone?
Yeah, he was talking about Riemann surfaces.
Ooh.
And I was like locked in for it, but I had to go teach. I was just on his stream as well. I was asking him about like his notes on linear algebra and everything. I feel like I've been in everyone's chat, but because my Discord name and
yes,
Twitch
chaotic
name is
dude. No one
different.
knows who chaotic dude is. Go make a Ramton Discord, dude. Go make a Ramton Discord.
I gotta change. But yeah, I was gonna ask you if are you doing the 10-hour stream tomorrow?
Tomorrow, yep. Yeah, we're doing it tomorrow. Wow,
Okay.
Penn Center just raided us. Speak of the devil.
Yeah,
What's up, Penn?
He was just finishing.
He was just finishing. Nice.
Yeah. Now he might know my voice. You know?
Yes. So Penn Center. Yeah. Now do you know chaotic dude is Rampton? What's up, Penn? Good to see you. Famish is here too. Yeah, nice. All the boys, girls, and friends, and all the fun stuff. Nice. I'm glad Penn Center is streaming again. I felt like I missed some Penn Center in my life, honestly. Yes, I'm doing a 10-hour stream tomorrow. Yeah. Yep, I'm gonna do it.
I'm gonna be around. When are you starting it?
4 o'clock.
Be around.
So an hour and 20 minutes before whatever this time is.
Wait, you're starting at 4 p.m.
Yeah.
And then you're going till 4 a.m.
2 a.m. 10 hours, not 12.
2 a.m. Okay.
I'm not crazy.
Okay, yeah. I can't do math apparently.
Yeah.
I thought you were gonna be okay. Why don't you start it earlier so I can join in for it?
I have
It's
meetings.
So late for me.
I know. I have meetings during the day. Yeah.
Oh, okay. Yeah. Okay. If I'm around, I'm gonna try to join. I wanted to like hop on now, but
yeah.
I
You're all
answered
good.
a bunch of questions in the thing.
Yeah.
So it was the Laplace transfer was pretty fun.
Oh, are you talking about the ones in our Discord?
Yeah.
These? Yeah. I saw you did some, and then Clickbait did some. Yeah, no, I appreciate you guys doing all these. This is Narovsky was on his game at 10 a.m. Dude, so many dope people who just keep answering questions in our Discord. Like, thank you guys. That's why I keep telling the students, like, even if the queue looks hella long and it doesn't look like we're gonna get to it during the stream, I have such an amazing group of friends who also just love to just do this shit in their free time. And we have like unlimited amounts of questions that can be answered. It's a fun.
Yeah, I've been looking through it to try to answer all of the ones I know.
Yeah. Penn Center, you can totally join me in the VC. 100% Penn. Penn, you're always welcome on my stage. Just like Rampton. Y'all have very special perms. You should be able to just get on the stage. Provided that Rampton doesn't get arrested, dude. What's with the police cars? No. Are they taking you back, dude?
It's just no. It's like essentially I live right at the corner where there's just a fire truck and cops always pass by.
Yeah.
So that it just picks up very easily on my mic.
I'm
in a condo also, so I don't know how well like picks up so well.
You have to see. Oh, Gold, can I see 16? Yes, right, let me show you. Well, also, Equity, all of this, I will post all the solutions to this will get posted inside the Discord. Yeah, good question, Clickbait. You're saying, can you remove the tag? I don't know exactly. I'm new to like Discord forums, but I've been manually going through and removing the unsolved tag. But if you go here to right click on edit tags, let me know if you can see this or if I have to give you permissions for it. They're not very clear on Discord, like with what the perms are in order to remove tags. I'm honestly like confused at it. You know, like if I go to like here, I'll show you guys. If I go to like settings, permissions, here, actual educators, which would be you guys. I don't know where the perm is to like remove tags. I see like I put manage messages, so you're able to delete posts, and I would think this would also now enable you to do it. Manage posts, right? This one should have let you do it. You need help with quantum physics. Oh, okay. Submit a question, JQ. We'll go for it. Do you take psychology questions? Are you asking about my psychology or like just in general? I don't know very much about like formal psychology, but maybe someone on my stream does. Also, I want my Discord. I want my not my Discord. I want my TikTok chat to show up here. One sec. I'm getting mad at this. Refresh, please. Yeah. Okay. And then wait, what was this one we were doing? Last one here. And then I will get back to all the people's. So this is how you get everything to cosecant. And then this is not very easily factorable, right? I don't know what multiplies to 3 but adds up to 2 squared of 2.
Disqualified.
No. That's like kind of weird, right? I don't understand that one. I think you have to do the quadratic equation here, which is unfortunate. So what's that? 2 squared of 2 plus or minus the square root of b squared. So that's 4 and 2, which is 8. Minus 12. Oh, this is imaginary. No. All over 2. Okay. So 2 square root of 2 plus or minus 2i all over 2. Right? Because this would be negative 4i. Or negative 4, which is, yeah, plus or minus 2i. Oh, Pen Center can see the unsolving. You can see, yeah, but can you remove the tag, Pen Center? I think that's the question. How do I give people perms to remove tags? Because what happens is in this Discord, in this stream, when I finish, I click a button and it posts everything that hasn't been answered automatically to the Discord, and it assigns it the unsolved tag. But then if someone solves it, I want them to be able to remove the tag. I think it's just Gauss's law. Okay. Yeah, clickbait. One sec. Let me give you permissions. Wait, did I not give you... One sec. I thought I gave you Physics God. Didn't I give you Physics God clickbait? Alright, try it now. Clickbait. See if those perms do it for you. Ampere's law. Oh, right click, edit tags. Okay, so Pen Center can do it. Nice. Well, Pen is kind of like a admin almost in my server, so I need to see if it's the right positions, the right permissions. I don't want to give everyone like admin perms.
Disqualified.
Okay. Anyways, nice, cool, good question here, Equity. I'll post a solution so you can look at it. This is kind of more like pre-calc, I think, Snowman. All right, and then let's go post it. So where's my thing? Where's my thing? Not there. Too many things open. There we go. All right, Mark is done. So then what's gonna happen, Equity, just for, so you see how your post comes in here, and then I'm gonna drag the full screenshot in so you can look at it later. And it's right there. Wow. Okay. Do I write it in factored form? Oh, yeah, well, I don't think... Thank you, Sam. I do need to hydrate. I don't think you could factor this one. I think that was kind of our... This can't really be factored. I don't know how to factor 2 squared of 2 on the middle term. Like, what? We can solve JEE questions. No, don't speak about JEE, please. Demi, just go to that website, actualofficehours.com. It should allow you to upload a photo, a screenshot. Yeah, for those that are watching, the website is www.actualofficehours.com. type in your username. I don't care what it is, whatever you want me to call you. Drop a screenshot in, hit upload. It'll get added. And then here's the queue so far. If you ever want to see what somebody's question is, you can just click on it. And it'll show you what they've submitted. And then also, if you want to find out when all of our other awesome, lovely streamer friends are streaming, you can click here on streaming schedule, and this will pull up a calendar of everything. So I love this. The calendar is very full, which is great. So, except no one's really streaming tomorrow except for me. But Friday, yes, Penn Center has a special event. Awesome. I have to extend this out because I'm going to be streaming for a while. But yeah, make sure go there, check out all the other awesome streamers that are on. Wait. What is someone saying? You forgot to move the -1 to the end with the +3i. Where's the +3i? What do you mean +3i? 3i? B squared minus... Wait. What are you guys talking about? What? Yeah, exactly. Yeah, okay. Thank you, Clickbait. Yeah, let me add that. That's a great idea. Yeah, okay, I'm gonna do that. I wonder if I can code that. If not, it's another thing for me to vibe code at some point. Yeah. Make solved to remove the unsolved. Okay, one sec. Oh, I did fuck that up. Oh, you're sorry. Oh yeah, sorry. This goes over here. Oh, yeah, yep. Sorry, this goes away, and then what? This becomes +2. And then wait, how is that all of a sudden solvable? Because that's still u squared minus 2 squared of 2u plus 2. Oh, is this square root of 2 square root of 2? That's goofy, bro. I've never seen that. What? Really? I mean, I guess it works. Oh, okay. So you get u minus square root of 2 squared. Oh, very cool. And then that's cosecant of x minus the square root of 2. Okay, cool. All right. I guess that works. I mean, very rarely will you see a teacher asking you to factor something where you have to figure out that they're square roots of things. That's not very fun. That's actually quite mean of your teacher. Right? Arithmetic arena. That's cool. I can definitely do parametrics. Yeah. I want my... This is not working. Oh, there we go. We just need WebSockets. Okay, great. Okay, now the TikTok's working. Excellent. I don't know why that took so long. All right, nice. And we got another... Oh, thanks for the sub, Jarkeezy. UG, bro. Appreciate it. All right, let's get the next question up. All right, so I'm going to go to the queue. Clickbait, you got the next one for me. Looks like we're doing Laplacian and spherical. Oh, I might need Rampton's help on this one. I just don't want to do... I don't like Laplacians. What is this? Show by explicit calculations that the Laplacian and spherical coordinates has the form this. Oh. Wait, it just wants to show this? I'm actually interested. Wait,
yeah, you have to do the transformation from the XY plane to the
is this
what's it
X
called?
Is it this R cosine theta sine phi? Y equals R sine theta sine phi?
Sine phi, and then
Z equals R cosine phi?
Yeah, hopefully. Yeah. I'm trying to see if that's the same theta and phi they're using. Yeah, I think that should.
Oh yeah, because physics and like math are different.
Yeah, sometimes they like switch up the theta and phi.
Yeah, they do. Yeah. This is the way I learned how to do it. Yeah. Okay, cool. And then, I mean, div squared is that like, is div squared equal to like div dot div? Is that what that is?
Yeah, it's the second derivative squared. Yeah, technically it's that. Yeah.
Wait, so is this the same thing as like d squared dx squared, like x
X
hat,
squared.
comma, yeah, whatever y hat?
Because as a dot product, it would just be add addition then. It would be
Yes. These are spherical
yeah, so
coordinates.
it would be d squared dx squared plus d squared dy.
Okay. But this is a vector then, no?
No,
Oh, it's an operator, I guess technically.
it's a yeah. It becomes a scalar because, as you said, it's a dot product.
Okay, because it's div
Yeah.
dot div. Yeah,
You
and the
have to-
dot product is okay.
Yeah, you kind of have to do this with using chain rules.
Okay. So, what are both our degrees? Physics. We have physics degrees. Okay. So what I do? Well, if I want
so you have to like show the
Is it-
ddx in terms of the other things using chain rule.
Okay. So I do ddx of what?
Yeah. So that operator itself is just equals to dr dx ddr,
Okay.
and then plus or I guess partials,
Okay. Yeah.
and
technically.
then yeah.
Oh, partial x, partial
Yeah, partial
x,
and then it would be it would just be ddr, I guess.
partial r. Oh,
Yeah, and
okay.
then
Got you.
plus,
Yes.
d theta dx.
Wait. You mean d? Yeah. Okay. D theta, dx,
dx.
dd theta.
Yeah, and then plus
Oh.
d phi
Oh
dx.
wow. Oh, this is
Yeah,
pretty cool,
it's-
actually.
It's and then you have to do that again after you do the
Wait. But
First-
dr. Wait. But this is dr dx. But wait. So do I need r in terms? Well, I mean, r is equal to x squared plus y squared plus z squared, right? Am I allowed to say that? So then dr dx is just equal to
dr
2x.
wait, am I
I think we're
doing this
tripping.
wrong?
I think we're tripping. What's up, Scrimbo?
Wait, no, I think the x it should come out as dx dr.
You got to transform the basis unit vectors. Uh-oh.
Yeah, I think
Clickbait.
you already have done that.
I mean, isn't this also a unit vector technically? And these are also unit vectors.
Yeah. Those are the so x or r is wait, no, I think this should come out to give you wait, why is it coming out the other way? Because I'm pretty sure the first one is just going to be you're just taking the derivative of all of those terms
Yeah.
in x with respect to different variables.
Oh, so wait, this should be dxdr, not drdx.
Yeah, I think. But then it would.
Yeah, this is kind of like Calc 3. This is Calc 3. Okay, one sec. I'm gonna go use some chat for inspiration. Chat, give me some inspiration here, dog. I trust you. Where are Ramton and I messing up on Calc 3? Bum, bum, bum.
Wait, no, yeah. Sorry, you're right.
Oh, I was
Yeah,
right?
So it does become the dr. Yeah. So when you do the dr dx,
Okay.
yeah, do it. So the dr dx becomes so
2x.
r is the square root of that, right?
Oh, true. Oh, okay.
Yeah.
Oh,
so then
oh.
dr dx becomes 2x over.
Well, it becomes 1/2 x squared plus,
Half,
or one,
yeah.
or I should put r squared in there, right? So it's 1 because this is all just r squared.
But you're just taking the derivative of r with respect to x, right?
Yes.
So you're just doing the partial of that.
So this is still a chain rule though. So this is 1/2 x squared plus y squared plus z squared to the negative 1/2.
1/2,
right?
yeah.
And then times 2x.
Times 2x, exactly.
Exactly.
Yeah, and then that becomes x over r.
Right. Okay. Oh, this is very cool
Yeah.
actually. Okay.
Yeah.
Here, let me clear this because down here so people can understand. The y and the z are constant, sin b. Yeah. The issue is that this is a chain rule, right? Whereby this whole thing here is like to the 1/2. It's actually like so the square roots look weird. Let's just do it this way. So if I take the derivative of this, right, sin b, I have to pull this down out front, drop the power, and then take the derivative of what's inside. So this is going to be equal to 1/2, and then it's all this to the power minus 1. So that's going to be negative 1/2. Then I take the derivative of what's inside, which is equal to 2x, so times 2x. And then Ramton pointed out, right? The 2's cancel.
Yeah.
And so I'm just left with x over the square root of x squared plus y squared, bless you, plus z squared.
Sorry, thank you.
But this is the same thing as the square root of r squared, so you just get x over r.
Yeah, and then you put the x as what it's equals to, r cos theta sine theta.
Oh, this is so sick. Okay, I see this.
And then
Yeah,
it
yeah,
just becomes cos theta sine theta as the...
Okay, and so then, yes, and then so from this, right here, let's see, from this, yeah, you have r cos theta sine phi all over r. This cancels. Okay, so you just get cosine theta sine phi.
Yeah.
And then it's still DDR, right?
Yeah. And
Okay.
then, so ddx technically is cos theta sine theta dd.
But that's only one component of it. We also still have to do d
That's one
theta
of the
dx.
components. Yeah, and then
Yeah,
you have
okay.
to do the d theta dx as well.
Okay, not too bad.
And then theta...
Tavian, because I don't know everything, Tavian. I'm rusty on this, so I the guest is helping me out. That's why this works. It's called teamwork. Okay, d theta though. Third term is a bitch so
Yeah.
far. I bet it is. Wait. So
I think
theta.
third term is the easier one. Theta is the bitch.
Oh, you think? Oh, because phi is easy, right? Because
Yeah.
phi is equal to the
Yeah,
arc cosine of z over 4.
Cosine phi. No, you have to do it like the tangent of y over x. It's the
Oh, I see.
polar angle. Yeah, tan
I
theta. Sorry.
Arctan,
Yeah,
right?
that's why I'm just trying to figure out. Yeah, so tan inverse y over x.
Is
yeah.
it y over x though?
And then
I thought.
I think this because they're taking this one to be the polar angle. So
This is
it's the angle
the
between
azimuthal one. This is this one. Got you. Okay.
Yeah.
Wait a
okay.
minute. No. But for the z coordinate, that depends on the angle it makes with the z axis. No.
Yeah. So this is the x and the y axis. I think we're just flipping the terminology at this
No.
point.
No. I'm pretty sure. Okay, watch it. I'm pretty sure.
Wait, are you? Oh yeah, you're taking the theta. So sorry, you're correct. Then the other
I'm
one
correct,
should
right?
be,
I consider phi this way because I'm not a heathen.
is there 5 from the z-axis?
Yeah. We do everything Cine B, everything math science, middle school through high school. This is the convention
Yeah.
I'm using. I'm pretty sure that this is it, right? Because then r cosine
Okay,
phi gives me
yeah.
z, right?
Yes, yeah. Sorry. Then in that case, theta was.
Theta's the
tan
easier
inverse.
one. Yes, okay, then I agree.
Theta
Okay,
is
so
easier,
theta is
yeah.
measured from the x-axis. Okay, cool. All right, so
Yeah.
that's fine. All right, so let's do that one real quick because that one's probably pretty easy, right? Because I just got to take a derivative of arctan. Okay, so for theta, arctangent of y over x is equal to theta. So then d theta dx is equal to the derivative of arctangent, which is 1 over 1 plus y squared over x squared. And then it's times negative y over x squared.
Yeah.
Right? Okay, so that's that chain rule. And then does this turn into some nice magic? Maybe.
Yeah, because the x squared with
Oh, this is negative y over
x
squared plus y squared. Oh, bingo.
y squared. Yeah.
This is negative y over r squared. Oh. Oh, fuck. That's cool. And then y is equal to r sine theta sine phi, right?
Yeah.
Oh, this is actually pretty cool. Oh, I like this. This is actually really cool. I'm no longer scared. Okay, so that cancels. So I get sine theta sine phi over r. And then ddr? Or dd theta, right?
Theta. Yeah.
Okay, so it's that plus sine theta sine phi dd theta. Okay, cool. And then, oh yeah, phi is a...
You done messed up, Aaron!
Phi's the arc cosine of z over r. Oh wait, so okay, wait. So for phi, z arc cosine of z over r is equal to phi, right? And then I just have to rewrite r as square root of x squared plus y squared plus z squared.
Yes.
Okay. And then just do d phi dz or dx, d phi dx. Okay, but whatever, this fucking blows. You know what? the derivative of arc cosine and then with another chain rule. Do I want to do that? I don't know. What is the derivative of arc cosine?
One thing I was the other one that you wrote down, I think, yeah, the other one is just a nightmare, honestly, the theta
This one.
But the other one, you have x squared. Yeah, this one's a nightmare. But the other one, you have x squared plus y squared, so it's not quite r squared.
Oh, it's r squared minus
r
z squared. Sorry, r minus z squared.
Yeah.
Wait.
Or in other words, is
Sorry,
like
I was getting my polar coordinates messed up.
Yeah, I feel like I always mess this up. But then it's if you use the expressions from the x and y.
Yes. I know what you're saying. I know what you're saying here. Yeah, because x squared plus y squared will you still get a cosine squared sine squared phi. So
so it would just be r squared sine squared.
Oh, it's just r squared sine squared phi, right?
Yeah.
So negative y over r squared sine squared phi, and then y is equal to r sine theta sine phi. Negative r sine theta sine phi over r squared sine squared phi. Okay, cool. That cancels. That cancels. You should try Fubini. It's so cool. You can integrate 3 times. I don't want to do that, do I? I don't think I need to for this question, guys. Negative sine theta. Yeah, Fubini. That's just like changing the limits or like the order of operations, right? On the order of the bounds, I think, is what Fubini's theorem is. Yeah. Okay, so do we agree? I think that's right, right?
Yeah.
Okay. So then it's...
I gotta look up Fubini.
Yeah, Fubini's theorem just says that you can separate the integrals out by like whatever variables are dependent within whatever bounds. I'm pretty sure.
Oh, yeah, okay, that's what... Yeah. Wait, how did Fubini come up with that?
I don't know. Someone's probably just trolling in my chat.
Okay, I was like... That's what...
Okay.
Yeah, this one's gonna be a night. So
I'm not gonna do this one.
Negative...
Here, let's just save this for
Negative
later.
1...
Save for later.
Yeah.
I'm gonna save this for later
because
the queue's already at 12 questions.
This would then you have to do this again. Because
but luckily the question said only do delta squared delta x squared.
Yeah, that's what I'm saying. But you're only on the first derivative so far.
Oh, get out of here, dude. What?
Yeah.
No, dude, no. Dude, clickbait. Why does your teacher choose violence, dude? That's so much violence. So much violence. Okay. All right, cool. Well, you know, good question, clickbait. you always bring the fun ones. I will say. All right, let's mark that as done. And let's put that into here so far. Cool question, click. It's for quantum. We're using for the Hamiltonian spherical for angular. Okay, makes sense. It's just weird they're making you like rederive it. Okay. Jarkizi, find the inverse of the following matrix. Oh, okay, cool. If this is, I mean, I'll show the general way to do it, and then I'm just gonna have the calculator do it. Because I'm not doing all the row ops. I'm pretty sure that would take a while. The way I always do these is I just append a matrix to it, right? So I'm gonna do this. And then I'm gonna do 1 0 0 0 1 0 0 0 1. He said every physicist should derive this at least once in their life. I'm not the biggest fan of those types of people who are like, my life was pain.
I have done that once in my life.
Right?
That
No,
was
I'm sure.
enough.
Yeah, I don't even think you need to go through that. Like, what? Just because you starved in a communist Soviet Russian breadline doesn't mean everyone else needs to.
But the good thing is because you're doing the X one and the Y one, you kind of see a pattern, so you can just guess the Y and the Z one based on how the partial derivatives
I
look.
see. Yeah, because they probably all they pass out. So okay, when I want to invert a matrix, let's say for instance, I do Ahmed. Yeah, submit your screenshot. I'll go through it. Yeah, that's a great question. Also, we have other chem people who do chemistry stuff, so they'd help you out. My goal is always to like turn this into this somehow using like row operations. So, off the rip, right? I would just like replace row 1 and row 3 with each other. So now you'd have like 1 2 3 4 2 1 3 negative 1 2. And now this becomes 0 0 1 0 1 0 1 0 0. This is Gauss-Jordan, yeah. And then your goal is, and this is how calculators do it, you do what's called like the snake method. So you go down this way, trying to turn this into like 1 0 0, and then you try and come up to turn this into like 0 1 0, and then you come around and make this like 0 0 1. And it's a bunch of fucking nasty row operations. I'm not going to do all of them, but I'll show you what the final answer is, I guess, at the end. I'll do the first couple of them, and then you just have to do it. It builds character. But for instance, so if you did negative 4R1 plus R2 and just had that equal to R2. Luckily, copy pasting makes this like not too terrible. Okay, but then, so negative 4 times 1 plus negative 4 is 0, right? So this is 0, and then you got negative 8 plus 2, which is negative 6, and then negative 12 plus 1, which is negative 11, and then it's 0, 1, and then negative 4. Just because you have to wait in a communist line doing snake operations doesn't mean everyone does gold. I don't think there's a faster way to do this. This is just pain. Dude, finding inverses of 3x3 matrices is just painful. And then here, the next one you would have done is you would do negative 3 times R1 plus R3 goes to R3. It builds character, comrade. Yeah, dude. You know, I heard a great quote that said that, like, every generation needs to burn their hand on the pot thinking communism works. We never learn until we hurt ourselves, and so like every generation like toys with the idea that communism and socialism is like viable, and then like the breadlines start.
Surprise, motherfucker.
What's up, Unc? What's up? Yeah, Gaussian elimination. So this plus this, that's 0. Negative 3 times 2 is negative 6. Negative 6 minus 1 is negative 7. Negative 9 plus 2 is negative 7 as well. And then this is 1, 0, negative 3. Okay, congrats. You're a third of the way there because you've at least gotten to 1, 0, 0. Your next goal is to get from here to 0, 1, 0. And then you have to go from 0, 0, 1. It sucks. I'm going to show you the easy way to do it in your calculator, though. Okay? This is not my gold calculator. This is wrong. One sec. Let me fix this calculator. I'll let you guys talk in chat while I fix it real quick. Where are you, calculator? Yeah, if you want to submit a screenshot of the question, Bender, I'll do it. I'll do it on the stream here. I'll do it right now. Well, not right now, but I'll do it today. We're already at 13. They keep building. Show me how to do the Casio FX. No, dude, I don't have the Casio, dude. No. This is we are a TI 84 Master Race family here. Anyways, you go to second matrix. You're gonna go to edit here. You're gonna turn this into a 3x3. So you can just say like 3x3, and then you just plug your numbers in: 3, -1, 2, 4, 2, 1, 1, 2, 3. And then here's the beautiful thing, dude. Just go to your main home here. Go second matrix. Matrix A is the 3x3 we just created. And you literally just raise it to the -1. And there you go. Look at that hot fucking garbage. That's terrible, dude. Yeah, dude, this sucks. This is not a fun matrix to invert. Anyways, there's your solution if you wanted it. Sometimes you can have it like go to fraction. I wonder if I can. Oh, okay. Ooh, it did do it. This is actually really cool. It did put it in fractions. Fractional form is at least nicer. Yeah, you're not cooked. I mean, it just takes a while. It just sucks. But there you go. That's eventually the answer you should get. So, based on this, I think you would... And Fembox showed me this, actually, when we were doing Gauss Jordan. Don't worry, actually, about making everything 1. In this case, I think you want everything to be, like, factors of 35. Like, once you start having to divide things, don't do it. Like, just try to get, like, a number here. 0, 0, 0. Like, another number here. 0, 0, 0. Another number here. And then you can divide everything by whatever this number is at the very end. And it looks like, in this case, since 35 has factors of 7 and 5, I think 35 is going to be your, like... That's going to be your highest number, probably. The TI-84 rules so hard. Thank you, Fembox. It does. It's fucking awesome. Okay, anyways. Good question there. Appreciate it. Jarkeezy.
Well done! Well done!
Alright, then we got Deem Scrotter coming up. Yo, what's up, Zach? Good to see you, Zach. Eat the 2i pie. Nice. Zach's another awesome math streamer who has a very... You have a very fun schedule. You have a lot more variety in your schedule, Zach. I need to do more of that. I just get so bogged down by everyone asking questions. But you and Penn Center are doing a podcast on Friday. It's kind of like a Between Two Ferns, but not. And I saw you had something with the collar cone today. I was at the gym actually watching. I forgot to say something during it. Penn Center podcast. Yes, there's a podcast going on. Yes. If you guys want to hear some awesome math people talk about math and other things and dad jokes, again, head over to the streaming schedule right here on actualofficehours.com. And then it's this special event happening here on Friday at 10 a.m. It looks like my time. Okay, so I'll probably be awake. Oh, y'all should probably put in here. Put the links because I know you're hosting it on YouTube and on Discord, Twitch, I think, right? Not gonna lie, I'm being shameless and just passing my homework to you, but it'll help me learn. I mean, that's the whole point of the stream, dude. Yeah, no, you are 100% allowed to send me your homework. Just don't send me all your homework. I won't do all your homework. I'll do some of it, or I'll do enough for you to learn. We did work on the Laplacian. This was how far we got. We got to the first derivative in terms of theta, the first derivative in terms of r, and then I didn't want to do anymore. So that's it. Save for later. It's an exercise for the reader, right? Classic. Yeah, but if I do all your homework DMs, you don't learn anything. Okay, I'm gonna do task E. This is kind of a fun one. What's up, Drew? Good to see you, dude. Clickbait wanted you to ask that one. Wow, okay. We got partway into it, and then I was like, the queue's already at 13 questions. So we gotta move on. All right, function f of x. So this is cool. People ask me like, when am I gonna use the quadratic formula? Or like, when will I use anything in math? This is a beautiful example of something that math directly relates to. Selling tickets. If you want to be an artist, if you want to be any sort of like performing, you know, arts type person, the number one thing you need to do is sell tickets. Otherwise, it's a hobby. So a very cool problem that comes up when you're trying to sell tickets to something is, how much do I price my tickets at? Because if you price your tickets too low, sure, a lot of people will buy them, but you won't make any money, right? You know, if I sold tickets at $1 and 100 people buy them, like, okay, cool, I've netted $100, but it probably cost me like $1,000 to rent the venue out. So that's like not a good strat. Conversely, right? If you charge too much for tickets, then nobody wants to buy your tickets. So you could charge $20 a ticket, but maybe that's like out of the price range of your customers, and you only sell 3 tickets. Well, now you made even less money. You only made $60. So usually there's some sweet spot that it's like you're not charging too much, and you're not charging too little, and the most people per dollar will buy that. Yeah. So here they say, okay, this function models the revenue a school would earn from selling raffle tickets at 200x minus 5x squared when the raffle tickets are X dollars each. There, of course, yes, there are a gazillion other factors. So this is revenue, by the way, right? So this is rev. Revenue is how much money you take in for you finance people. This is not profit. Profit depends on other things. You have to subtract the costs as well. But let's say, for instance, that the revenue I pull in is modeled simply as 200x minus 5x squared. You're right, DMs. In reality, there are a bunch of other factors here, such as, I don't know, like, you know, what day of the week are you doing it at? What time are you doing it? I don't know, like, how much money did you spend on the advertising? There's a lot of other things that factor here. This is strictly looking at what does the price of the ticket X do to affect my revenue. So it says, if the school sells tickets for $2 each, how much revenue would they generate? So that's pretty cool. So that's just f of 2, right? $2 each means X is equal to $2. And so this gets you 200 times 2, which is 400, minus 5 times 2 squared, so minus 20. So that would be equal to $380. Nice. That's cool. At what price per ticket would the school collect $0? Well, I mean, that would happen if the ticket price was also $0, right? I mean, that's what we call the trivial solution. Yeah. Wait, who's saying negative 380? Okay, 40 maybe. Okay, so watch. So for part B here, we want to see when the revenue is 0. So I'm going to say 0 is equal to 200x minus 5x squared. They lose money if they sell it 2? I don't think they lose money if they sell it 2. No. So Swad, you plug in 2 for x. 2 times 200 is 400. Minus 5 times 2 squared. 2 squared is 4. 5 times 4 is 20. 400 minus 20 is $380. So yeah, they definitely make money. I mean, assuming they have no costs. Let's assume they're doing this at the school, and the school isn't charging them to host the event. Your mind is backwards. Totally cool, Swat. It's fine, dude. Yeah, it's Wednesday, bro. Okay, but let's see what happens if they wanted to make $0. All right. So 0 is now equal to this. This is a beautiful example of where factoring would be nice. So I'm going to pull out a 5x from each thing. That's going to give me 40 minus x. Okay, because 5x times 40 is 200x. 5x times x is x squared. Good. I just took the 5 out. Because now it's easy to see there are two solutions, right? So I can either have this thing equal 0. Because 0 times whatever, I don't care what it is going to be 0. So that happens at x equals 0. This one happens at x equals 40. Okay. So, yeah, at what price would the school make $0? Well, if they sold the tickets for free. But I think in reality, they're saying if the tickets were $40. And so that kind of tells you, like, $40 is where it's, like, too high. Like, nobody will buy a $40 ticket, so you won't make any money. And also, if the tickets are $0, you make no money. That's where this comes from. So what price would generate the highest revenue? Okay, so that's kind of cool. This is where, again, math comes in handy. This is called like not optimizing maybe, or like maximizing. There's a name for it. This is probably like, I would say this is pre-calc or algebra. Okay, so the highest revenue. So here's a cool thing. So if f of x is equal to, I'm going to rearrange this to make this look a little bit better. I'm going to say negative 5x squared plus 200x. Optimization. I feel like it is optimization, Zach. Yeah, right? Yeah. There's a name for it, technically. I don't know what a greedy algorithm is. So this is going to look like a sad face, right? Because it's a quadratic, because the highest power is x squared, and because there's a negative out front, that means it's sad. If this was positive, then this would be a happy face. But this is negative. Okay. So since this is also called the leading coefficient. Since the leading coefficient is negative, I know it looks like this. This is called concave down. And so whatever the vertex is of this quadratic is, that's going to be the maximum. Yeah. Maybe it's algebra 1. Okay, so the ways to do this, to find the vertex, the way I think they want you to do it, because you haven't learned derivatives yet. If you know calculus, this is easy. Like GG, you just take the derivative, you're done. I think they want you to put this into vertex form. And so what vertex form is... Yeah, submit a screenshot of a question, and I will do it. Yeah. Don't just, like, blanket tell me, like, hey, can you do an optimization question? Like, help me help you. Go find me one, and I'll do it. This is what vertex form is for a quadratic. And then the vertex here is at h comma k. Right? So, currently, we have y is equal to negative 5x squared plus 200x. I want to turn it into this. The way to do that is called completing the square. This is why completing the square is dope. I know some people are like, oh, just use the quadratic formula. Like, yes, if I'm solving for 0, quadratic formula is great. If I'm trying to complete the square, though, sorry, if I'm trying to get in vertex form, completing the square is a better way to do it. So, what we do is, in completing the square, I need to make sure whatever is in front of this x squared is just a 1. So I'm going to pull the minus 5 out. So we're going to go y is equal to minus 5, and then what's left here as factor in the factored form is going to be x squared minus 40x. Okay? You can always double check. Just multiply back through. Make sure you get the same thing. I do. So my next step here, it's the best dang thing. Yeah, I fucking love completing the square. My next step here is to do 40 divided by 2, which is then equal to 20, and then I square it. So I'm going to do plus 20 squared minus 20 squared, because effectively what I did is I just added 0, right? And that's legal. You can always add 0 to things. It doesn't do anything. Now what's cool is that this thing here is now a perfect square trinomial. That's by definition of doing, by design of doing completing the square. This will always turn out to be x minus, plus or minus, depends on this, whatever this is squared. So it's x minus 20, all of that's squared. But then don't forget, we still have the minus 20 squared here. So this minus 20 squared comes down, so say minus 20 squared. And then all of this is still enclosed with the negative 5 out front. Okay? So now you can run it back in. And you get negative 5, x minus 20 squared. And then this is minus 400. But then minus 400 times minus 5 is plus 2,000. Yeah, how do you know it's in the form to do completing the square? Well, because it was a quadratic, Mohammed, and they wanted the vertex, the standard way to get it into vertex form is to complete the square. You just kind of have to. It just works. You can memorize, like, cute things. I think it's like negative b over 2a is the x coordinate of the vertex, but then you got to plug it back in as well. I don't know, that just sucks. But this is done. And this is why this is very pretty. Because remember, that vertex form was this. So you just look, you're like, okay, minus h here is 20. Cool, so I'll say 20 comma, and then whatever's here is k, so that's 2,000. So this is your vertex. And then what's beautiful about this is this tells you what x is, which is the price of the ticket. And then this tells you the y value of the max, and so this is the maximum revenue. Negative b over 2a is, it is. Don't get me wrong, Liam, it is cool, but it's another thing for students to memorize, and I'm very much against just memorizing a ton of shit. I think it's better to understand a process, because completing the square gets used for so many other things anyways. You might as well just learn how to complete the square. If you know that trick and you're in competition math, yes, awesome. But then you would still have to plug it back in to get the y value. I ignored your request. If you submitted a screenshot, I'll get to it. Sorry, my chat is blowing the fuck up, so I'm sorry if I don't see every single thing that comes through chat. Okay, so there you go. So what price would generate the highest revenue? $20. And then how much revenue would that generate? That would generate $2,000. Nice. Okay, cool. Good question.
That's dope.
I'm gonna call here.
Cool.
It's been a long time.
No, you're good. You've been teaching forever, dude. You're good, man. I appreciate you coming by.
Yeah, yeah, no worries. I'll try to stop by tomorrow if I can.
Cool.
But yeah, I'll try to be around, and I'll also check out the stuff that you send me.
Yes, for the OBS stuff.
The videos. Yeah, I'll definitely make sure I check them out tomorrow. I have more time. Yeah.
Awesome.
All right.
Yeah, let's get you on. All right, peace. Thanks, Ramson.
Sounds good. Yeah. Have a good day.
Do you know Taylor Series? I do know Taylor Series, yeah. Submit a question. I will do it. Yes. Okay, to all the TikTokers who just found us and are probably confused at what the fuck's going on. If you go to the website, which is linked down below, actualofficehours.com, you can type in your username and you can drop a screenshot of a question you want me to go through. So this is a great way. If you have like an example, for instance, Taylor Series question you want to help with, or an example, I don't know, optimization problem. We just did an optimization one, but related rates, whatever. You can drop it in, and then this is the queue of questions I'm going through. And you can always click on someone's question just to see like what they're asking. Oh, this is cool. Oh, we're going to do series. I love that eventually. But the next question is Sibley. And Sibley's asking about coax cables. These are cool. This is physics. Yeah. All right. So it's about to get a little bit harder. Correct me if I'm wrong, Sib. You wanted me to do part B, I think? Determine the magnetic field. It's actually kind of cool. Okay. A coax cable is solid interconductor, radius R1, surrounded by a concentric cylindrical tube. Which one do I think is the hardest? I mean, they're all probably pretty hard. Okay, wait. The conductors carry equal and opposite currents. Oh, okay. Distributed uniformly across their cross sections. Determine the magnetic field at a distance R. Okay. Between R1 and R2? I would say the most difficult one is probably question A and question C, I think. Yes, it's for, yes. So this is, I believe it's Ampere's law, which says the integral of B dot dl is equal to mu naught I enclosed, right? So here's the cool thing. for when R is greater than R3, because you have current going to the left on the inside and to the right on the outside, and they're equal and opposite, when you are on the super outside, like outside R3, the total current you enclose is 0. So it's actually fun. So the answer for D is just equal to 0. There is no magnetic field. Let's look, for instance, at part A. So when R is less than R1. So again, so this is B times 2 pi R. So DL is like this imaginary... It's similar to Gaussian surfaces for electric fields, but you're doing like paths in magnetic. Yeah, Ampere was cheating off of Gauss's homework. Yeah. So, yeah. And correct me if I'm wrong. I think this has to do with like Green's theorem somehow. It looks like it, right? Because it's like a path integral is equal to like the flux or something coming through it. I forgot how it works. Oh, this is an example. Well, John, dude, the algorithm knows you're doing this, dude.
Good job.
Algorithm's always spying. Okay. It's a path instead of a surface. Exactly. So this is B.dl. So B times 2R is equal to mu naught. And this is where things get tricky. Which is like how much current are you enclosing? All right. So it's also similar to what we did with Gauss's law with like the non-conducting spheres where like the charge is uniformly distributed. You have an exam on this on Friday. Great. Okay, cool. Then this should help you. The charge enclosed is going to be equal to the volume. Sorry, it's not the volume. Sorry. It's equal to the surface area enclosed over the surface area total times I total. Okay. So in this case, when R is less than R1, that's going to be pi little r squared over pi R1 squared, and then this is times I. So then this cancels, okay? And then you can move, what is it? You can move the 2 pi r over, so you get B is equal to mu naught over 2 pi, and then r squared over r is going to just give you r, so you get r over R1 squared times I naught. Where do you teach? I teach at UCLA. I teach physics. This is the life science one. Now I'll tell you more after, but it's the same as the other one. Yeah, okay. This isn't too bad. In life sciences, I don't think they would do the integral part. They would just say it's B times 2 pi r. But okay. You seem like a beauty of a prof. Thank you. Wow, that's really nice. So between R1 and R2, this is interesting. So this was R is less than R1. When R is in between R1 and R2, explain the math. This comes like just from a rule. If you want me to derive Ampere's law, yeah, that might take a little longer. But in terms of the algebra, all we did was like take this, move it over, and then like this cancels out with one of these, and that's why this is this. And then you're good. Okay, so for when R is in between R1 and R2, you have B times 2 pi r again. This is always going to be B times 2 pi r. You can just leave it. All that's changing is the I enclosed. Okay? Now, when you're in this in-between land between R1 and R2, as you move out in terms of R, you don't enclose any more current. You're still enclosing the original I naught. Yeah, this is also why magnetics is usually taught after electrostatics, because there's a lot of similarities. So this is just I naught. This I enclosed is not a function of R. So then you just get B is equal to mu naught over 2 pi, and this is I naught, and that's like 1 over R. Okay. C is a little bit harder. So B times 2 pi r is equal to mu naught. Now here's the interesting thing. Okay. You are already enclosed. So when you're in between R2 and R3, you already enclose all of this I naught going to the left. So I'm gonna leave that as just like 1 I naught. But then you start enclosing I naught that's in the opposite direction. What's up, Bemsies? And so that's gonna be like minus I would say I naught, where this is going to be like R enclosed over R total, or sorry, surface area. Surface area enclosed over surface area total. Yes, I do. We're gonna do a convergence or divergence question next. So stay tuned. Someone did ask a series question. I'm doing it next. Okay, now for this is a little trickier because you have like this going on, and you're trying to figure out what is it? It's like this, right? This is like R now. But this is R2. And then this is R3. So the total area, so SA total is equal to pi R3 squared minus R2 squared. Right? Because it's a donut technically. I have a physics PhD. That physics is my main degree. Okay, that's the total surface area. But then the surface area enclosed is equal to pi little r squared minus R2 squared. Does this make sense? Because these are just it's really just like it's a circle minus the inside of the circle. So minus this. Then gets you like this part. And that's where this is from. Electrostatics, my beloved, right? Yeah, outside minus inside. Cool, great. Okay, so then this is equal to mu naught I naught, and then this is 1 minus so the pi's are going to cancel. So you get r squared minus R2 squared over R3 squared minus R2 squared. And then here's kind of a cool property, right? Once R, you can double check your work here. Once R goes all the way out to R3, right? So once you're looking at the magnetic field all the way out, notice how the numerator will become the same thing as the denominator. This will become 1. 1 minus 1 is 0. And that's why the B field at R3 and beyond is equal to 0. Okay. Cool. Yep, so that's how you do that one. Hope that made sense. Very good question. I appreciate it. Yeah, you're welcome. Any tips for maths or useful AI tools? I use ChatGPT all the time to like double check my work and maybe get inspiration if I'm stuck. So I think using AI responsibly is a great way to learn for sure. You're very welcome. Using Gauss's, yeah. Your intellectual and yeah, cool. Double E, nice. ChatGPT is not as good, especially at reading like circuit diagrams and stuff. I know that's kind of a thing it struggles with, but if you can get it to kind of do simple cases, it usually does a good job. What's up, Gomez? All right, let's mark that as done. What level is this? This is probably, I would say, undergrad physics. It could be AP physics as well. Yeah, it could be AP physics. You don't know? Yeah, dude, if sequences and series is probably one of the hardest things for calculus students to go through, which is why in my chat, we have a really awesome math streamer who's maybe lurking around. His name is Zach, e2iPi. He wrote his PhD thesis on the best way to teach sequences and series in calculus. Oh, no, sorry, not your PhD. You wrote your master's thesis. Sorry, his PhD thesis was on something else with grad school stuff in math. But his master's thesis was specifically on sequences and series is taught really badly in high schools and calculus classes. What is the best way to teach it? And so that's what he came up with. He has a, so he doesn't have a YouTube, well, he does have a YouTube channel. I don't know the link to it exactly, but you can also find him on Twitch. Twitch is where he mainly streams. And so if you want to figure out, his name is e2iPi, his name is Zach. So if you go to the website, actualofficehours.com, that everyone's submitting their questions, click here on streaming schedule. And then his name is e2iPi, so this guy, Zach. And then that's the link to his Twitch. He's not he streamed this morning. He's not streaming Thursday. He's technically streaming Friday, but not really math help. But Saturday is the next time that he's streaming. Saturday, 9 a.m. Pacific time. He has a stream where he does homework help. So if you want to get help with sequences and series, he's the guy. Yeah. 4th year Civi assignment. I could try to. I'm not an engineer by trade. I know math and science. Engineering is like, they start doing weird stuff. Okay. Yes, I can. Let me send you his Twitch name. Yeah, let me get it for you. One sec. No, that's mine. Twitch. Where's his Twitch? Yeah, give me 2 seconds. I'm gonna send it to you. I need my chat to open. Chat, open. There you go. Yeah, there's definitely electrical and computer people in chat that actually stream right now. I don't know specifically. I do a little bit of double E stuff for sure. Okay, what test or technique is appropriate to use in each case to determine convergence or divergence? Yeah, no. Please, yeah. So if you want to know more about everyone, please go join our Discord, and you'll see there's a whole community of people that do different math, science streams, help, or they're students. We actually reward students for like doing well in school by we buy them like gaming gift cards and stuff. Yeah. Okay, great. Yeah. So interesting. Yeah, go in there. Check it out. Yeah. Cool. Send me a DM if you're ever like you have questions. My name's Dr. Gold. I'm the admin. So Burrito Freak, yeah, if you like solving problems, we have so many unsolved problems that come in every day. Because as you see here, the queue's already at 13 questions. I only have an hour and 20 minutes left to stream. So anything I don't get to gets sent into my Discord, and then it's kind of an awesome, beautiful thing to watch other people jump in and help and just like post solutions to things. So if you're familiar with Discord, I invite you to join it, please. And then there's a role there you can get, which is specifically for people who help out other people. Yeah, there's Zach. There's Zach in my chat. That's Either2iPipe. Yes. Zach is the sequences and series master. All right, so yeah, let's talk about. Let's pull up what all the tests are. Yeah, because there is kind of an intuition that gets built with this, right? So let's see. Convergence test, and like there's like a cheat sheet. The Dirichlet test. Stop. What the fuck is a Dirichlet test? This isn't as sexy. There's a better one. Is it this one? Dude, there's one where I super fuck with it. Oh, man. It is this one, but I need it in better resolution. Dude, what's with this 200 pixel dog water stuff, dude? Come on. Yes. Okay, I like this one. I'm pretty sure I like this one. Yeah, okay, here. I'm getting this cheat sheet for you. The logarithm test, dude? Stop. Oh, yeah. All right, Shano, you got a question, Shano, about, what is it? I'm looking for advice on college algebra. I'm an undergraduate, and they're teaching all this algebra and expecting me to understand, know the background info, and it's starting to make me hate math. I'm sorry, dude. Yeah, I'm guessing there's like some fundamental stuff that you really like need to know, right? Like doing things with fractions, maybe, exponents. I know some people say it's basic, but I totally get it. It's foundational, and a lot of this stuff either didn't get taught during COVID, or maybe you're coming back to school and you haven't seen it in a bit. I think to make yourself not hate math, it's very, very important to at least understand like the basic building blocks, so you then have the tools and self-confidence to attack more complicated things. So if you need help with learning those fundamentals, I have like a free course you can run through that basically teaches and quizzes you on those fundamentals. And I think if you went through that, you'd maybe feel a little bit better about your math class. So yeah, join my Discord and send me a DM or something, and I'll link it to you. There's always real life applications to everything, dude. What? Okay, anyways. This is a great cheat sheet here, because it tells you like, hey, if the series looks like this, try to do something else, or try to do like one of these tests. So I can submit a screenshot. I'll do it. Looking at this, all right, I see like everything is like to the nth power. So this to me kind of looks like, and here, let me use a different color. Let's use red. This looks like pi. Actually, maybe not red. Maybe yellow? Oh, yeah, you guys can definitely see. Well, yellow's a little too bright. Maybe pink. No, I don't like that color either. Okay, I like this. Okay. This is the same thing as pi over e squared all to the n. Okay? That's what this looks like. All right? Which I believe you could run this as a p series, right? Can't you just run this as... Oh, this isn't a p series because it's to the n. My pi looks funny. Yeah. Comparison test. Okay. It is geometric. You know, you're right, it is geometric. So I think as long as this is less than 1, then you're good, right? And so pi over e squared. So e is 2.3. So squared is like probably 4 point something. Pi is 3 point something. So this is already something less than 1 to the n, right? And I think what you know is, you know by the geometric series, right? If r is less than 1, so if this thing is less than 1, then you converge. Yeah. So, good. Okay, cool. So, yeah, this I think you would do with geometric series. Which also is kind of like a comparison test. Geometric series. And I'm pretty sure this would converge. This one... I'm always tempted to do the ratio test, Zach. Right? I love the ratio test. Because, but I guess the ratio test only really works if you have n in the exponents, yeah? Yeah, I would limit compare to 1 over n. But let's see. 1 over n does not converge. Yeah, right? 1 over n diverges, right? And I think when you have this, right, if you divide everything by n. Oh, see the summary? Yeah, here's the summary. If you divide everything by n there, so a, I'm pretty sure converges. Because pi over e squared is less than 1. And that's all going to the n. Right? As long as you have a fraction to the n, that converges. Ooh! Oh, you could do the integral test. Yes. Yes, I think you could do the integral test. Right? Because this is an easy integral. Yeah. Yeah, beautiful. That's actually another cool thing. Yeah, so if something looks like an easy integral you could do, definitely do the integral test. And the way you do that, right, is you do the integral from like 1 to infinity of n over n squared plus 4. And so this is like, this is a u sub situation. You say like u is equal to n squared plus 4. So du is equal to 2n dn. So then this is equal to the integral from 1 to infinity. It's technically not 1. It's technically from 5 to infinity, but whatever. All right. 5 over infinity of 1/2 u to the minus 1. And if you integrate that, you get ln. Oh, that's cool. So you get 1/2 ln of infinity over 2, right? And so ln of infinity is undefined. No. Okay. Which is basically infinity. Okay. So yeah, this diverges. Pretty cool. Yeah, so that's another thing to look out for. If the thing you're trying to look, if the series you're trying to look at for convergence or divergence looks like a decent integral, just try to do that integral. Yeah. Well, ln of infinity is definitely infinity. I don't think that's like indefinite. That's just infinity. This, you could also limit. So this one I would not limit compare. This one I would do integral test. I think that's really clever. Whoever suggested that, great. So this I would do the integral test. This is a limit. This is a comparison test to the P series. So comparison to 1 over n squared. And basically what you're showing is that 1 over n squared converges, and since 1 over 2n squared is even smaller, that means that will converge. Sandwich test? Yeah, it is kind of a sandwich test. I think about the squeeze theorem when I think about the sandwiches though. So this converges by comparison. You got a test on this tomorrow at 9 a.m.? Best of luck to you, man. 1 over n squared. Okay. I think you say the same thing about this. This is all... like, the plus 3 and the minus 3 doesn't really matter. No. You don't really fucking care about the minus 3. So this is also a comparison. Nice. Yeah. So sequences and series is what distinguishes calculus AB from calculus BC. BC includes sequences and series. I guess there's a little bit of parametric in it, but it's really the sequences and series that makes this class difficult. And again, this is why Zach, E2IPy, has written a very extensive document for his master's thesis on how to properly teach this. Because I agree, this scares kids a lot. Because it seems pretty arbitrary, right? There's just all these random fucking grab bag of rules and tools that you're supposed to use. And, it doesn't seem like there's like a reason for why you use it. Oh, the comparison test? Only if n is greater than or equal to 2? Yeah, exactly. Yeah, so, exactly. Yeah, because this is n squared. If this was n to the first, this wouldn't work. If this was n to the third, you're still good.
Disqualified.
Yes. No, you're good. This one... well, this diverges by the limit test. Because the limit of this does not approach 0. Yeah, so this just diverges because the limit as n approaches infinity of n plus 1 over n plus 2 just equals 1. And in order for a series to converge, the last term, so the term at n equals infinity, has to go to 0. Yeah, nth term test. Yeah, I think that's a great way to say that. Yeah, cool. We can say, so D is ditto. And then E is going to be nth term test. Who do you think would win in a shake-off? Martin the King? Martin the King? You mean Martin Luther King? Or Helen Keller? Bro, dude. Okay, nth term test. All right, final one from F here. Okay. This, I think this is the alternating series. Right? Anytime you see a negative 1 to the n, you should think alternating series. That's the key thing here. So as long as you can show as that the function is like by magnitude getting smaller, which 1 over n cubed definitely gets smaller, and it alternates, it converges. So yeah, so F is alternating series test. And there you go. That's how you do all of them. Kind of fun.
That's dope.
That was actually fun. I liked going through all the little crash course and sequences and series.
Well done.
Nice. Whose question was that? That was Demi's. Thank you, Demi. I don't know what the sandwich test is. Can you give me a... Is it the limit comparison test? Is that the sandwich test? I've never heard of the sandwich test. But anyways, if you want all this work, like if you want this beautiful table that came in, it's also going to be on our Discord. So make sure, go join our Discord by going to that website, actualofficehours.com. You'll see Demi's question just got posted here, and then I will post the solution to Demi's question right here as well. And so you can follow up, you know, go take this if you want, and ask more questions. Yeah, you're very welcome, Watt. Appreciate it. Okay, cool. All right, that was Demi's. Okay, confidence intervals. Nice. We're doing a little bit of stats now. Zach's favorite. No, exactly. Yeah, no. It's very important to know series. Series messes up a lot of people, for sure. You're not alone. Okay. So this is, okay, so right off, stats is all about reading to see what tests you have. Okay, so proportions. Okay, so difference of two proportions has its own little equation for it, right? I think this is going to be like P1 minus P2 hat, something like this. Who engage in binge drinking versus the true that who wait, non-college who engage in binge drinking? Okay, cool. All right, so P1 is a proportion of college students. So this is college students that binge drink. And that's equal to 111 over 300. P2. Does he have any notes? Zach, do you have any notes? I mean, you have your thesis, I guess. But do you have any resources for chat about sequences and series? I mean, I say the table there is pretty good, but I do recall you maybe taught a course on it. Do you have recordings of that somewhere? I need to get on that. Okay. Zach's on it. One of the other, like, 19,000 things we need to do in life. All right, so P2 proportions. So these are the non-college. So kids who don't go to college, how much do they binge drink? And that's 98 out of 280. No, you're good. Okay, cool. And then we're trying to get a 95% confidence interval. Okay, so confidence intervals, just in general, just to tell you what they are. Confidence intervals is always like some like central value. So this is like what you think the value is. And then it's plus or minus some Z star alpha over 2 times like what's called like the standard error. So this is like the wiggle. I will do the next question in the queue, Sigmund. Yeah. All right, so the central value, right? So that's P1 minus P2 hat. So this is like what the average difference should be between college and non-college. So that should be 111 over 300 minus 98 over 280. All right, so let's get numbers for that. Sometimes this gets weird because you're like, are we pooling the variances or something? I don't know. There's always like a bunch of weird stuff. Where's the queue? Go to the website. If you go to the website and click on the live queue, you can see all the questions being asked and which ones are in the queue. If someone's submitted multiple ones, don't worry. I'll only do one of theirs. So just in interest of time. Also, if we don't get to your question, not to worry. I have an awesome group of other friends who love to help out and donate their time and answer questions. So as long as you submit it, it'll get added to our Discord and it may get answered at a later date. So no harm in submitting. 0.32. Like Zach did that today. Zach was streaming math help and he did some Laplace transform questions that got asked in my stream yesterday. He did them today. So it gets added to like the pool of like questions. Okay, so this is P1 hat. This is P2 hat. So this is the average proportion of college drinkers. This is the average proportion of non-college drinkers. Yes, submit it please, Batista. Yeah. So the average difference would be P1 minus P2 hat. This is the central value. And that's going to be equal to this minus this. So that's 0.048. Okay, good. All right. And then now we need to know Z star alpha over 2. So this depends on your confidence level. This is basically setting how big of a window or how big of an interval am I cool with trying to estimate my value. And that depends on how confident I am. If I want to be really confident, that window has to be huge. If I don't want to be very confident, the window can be a little bit smaller. It's a TI-84. So Z star alpha over 2, this is where things get tricky. It's like this value changes based on what test you're using. It also changes based on how many samples you have. I think I'm gonna use a standard Z value, which I think for 95%. Correct me if I'm wrong. Is that 1.96? What is it? Z score for 95%. Yeah, but okay, but that's 95%. I think that's in one tail though. I need a two-tailed. Yeah, this is the one I need. I need this. Oh, it is. Oh, it is. Okay, that is 95%. Okay, great. Yeah, 1.96. Nice. Sigmund, do I see your question in the queue? Yes, I do see it. It's right here. Here's your question. Nice. I will try to get to it. If I don't worry. It will get answered in my Discord. Okay, so this is going to be this, plus or minus 1.96. And then we need the standard error. Standard error in proportions, I believe, is usually equal to like the square root of p, 1 minus p. I think this is usually what it is. For difference in proportions, error difference of proportions. Here we go. Yeah, this is what it is. Oh, it's kind of a pain in the ass. That's why statistics sometimes sucks. Okay, this is apparently it. It's this, unfortunately. So it's p 1 minus p over n plus p2 1 minus p2 over n. Oh, sorry, I was kind of correct actually. This is for a single proportion. Okay. Okay, so standard error is gonna be equal to the square root. This is gonna be 0.37, 1 minus 0.37 over n, which is I think 300 people, right? Yeah. And then it's 0.321 over 1 minus 0.321 all over 280 people. Okay, let's see what that is on the calculator. Okay, so we have 0.37 times 1. Make sure you got a parentheses. 0.37 all over 300 plus 0.321 times 1 minus 0.321 all over 280. And then we square root that. Okay, so 0.039. Nice. Okay, so this is 0.039. Nice. Okay, so the upper end of our confidence interval is this plus this, and then the lower end is this minus this. So let's multiply that by 1.96. And then let's do 0.048 minus that. And then 0.048 plus that. So I get between 0.029 and 0.1225. Which is none of these. Well, okay. I can already start marking some off, though, I'm pretty sure. I'm pretty sure it has to be negative. So I don't think that is correct. I think the left one has to be negative. What do we get? 0.029. That's like close to here. But then I need it up to like 0.12. Like this looks pretty close to me for the right for the right side. Okay. Let's see. You can also here you can double check this with second. It's in stats. So you go stats, test, and we're gonna go to two 2 proportion Z interval. And then here we go. So x1 was 111 over 300. x2 was 98 over 280. Confidence level was 95%. So it gets minus 0.808581 and 0.0981. Okay, cool. Oh, interesting. Wait, one sec. Yeah. So that's exactly this one. All right, what? Sorry. But it says this is not 321. See how it says P2 is 0.35? Let's see what we messed up. I think I may have messed up this somewhere. Oh, it was 98 over 280. Damn it. I typed in 90 over 280. Okay. 98 over 280. Well, that changes everything. Because now this is 0.35. Oh, that's gross. Okay, one sec. 0.35. This is 0.35. That's why, you know, it's the TID4 is very cool because you can run a lot of these statistics tests just on your calculators to double check. And then that allows you to go back and figure out, like, hey, what did I do wrong here? So where was this one? It was, so, okay, this needed to be 0.37 minus 0.35. So that was equal to 0.02 right off the bat, right? That changed. And then this will probably change. So for this one, I'm going to do 0.35. And this is going to also be 0.35. Okay, cool. So that gets me 0.0015. All right, but we square root that. Oh, it's still 0.039, so it's 0.04 basically. Okay, and then we multiply that by 1.96. So I get 0.078. So you get 0.02 plus or minus 0.078. Which, yeah, bingo. Look at that. So 0.02 plus 0.078 is 0.098. 0.02 minus 0.078 is negative 0.058. Nice, good job. Almost sneezed. Wow. I'm not gonna sneeze.
Well done.
Okay. Nice. Very cool. Again, all stats is identifying what test you need to do and then just doing it. So, is there evidence of a difference between them? The answer for that is no. And the reason for that is that 0 is contained in the confidence interval. So if 0 is ever in your confidence interval, it means that there's a possibility the difference between the two things is nothing, which means that there is no difference. So you can say, like, fail to reject H0. Yeah. Cool. Nice. That's a really cool question. That's a great stats question. Whose was that? Jason. All right, let's post that up. Good, Jason. When is your question? Coming up soon. I'm doing one of Eric's real quick. Here, Eric, I'll do one of yours. And then I'm gonna just in the consideration of time that we have. All right. Mass is attached to a vertical. Okay, blah, 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 blah. The rope is attached. Okay, it makes angle theta. The ball travels at constant speed v. The tension in the rope. Great. Okay. This is always a good one. So draw up force diagrams. You have mg pointing down. You have tension pointing up here. And then that means that you're going to have some value for tx, sorry, ty, and some value for tx. And then if this is theta, that tells you this is also theta right here. Okay? Now here's a cool thing, right? So ty is equal to t sine theta. Or sorry, t cosine theta. Right? If this angle is theta, this angle is also theta, and then this is the adjacent side. This is weird. Usually ty is sine, but because we're dealing with this angle, it's cosine. And then tx is equal to t sine theta. Now here's the things. In order for this to be not falling up or down, I need ty to equal mg, right? So that tells me mg is equal to t cosine theta. All right. Additionally, in the x direction, so in this direction, because this thing is going around in a circle, it is going to experience centripetal acceleration inwards. So in the same direction that tx is pulling. And that's equal to v squared over r. So the sum of forces in the x direction, well, that's tx. So tx, which is equal to t sine theta, needs to equal the mass times acceleration in the x direction. So that's m centripetal acceleration, v squared over r. Cool? So they want to solve for the tension. Okay, so I have mg equals t cosine theta. And I also have t sine theta is equal to this. I want to get rid of the theta, I feel like. Oh, there's actually a cool way to do this. Yeah, okay. Okay, because also... Do they tell you about the radius? Yeah, watch. Oh, this is actually really tricky. So, this right here is the radius. That's equal to r. This is equal to L. So watch what happens here. So sine of theta, sine of this angle, is the opposite, which is, in terms of distances, the opposite is r over the hypotenuse. The hypotenuse is L. So now you can plug that in for here, and you get TR. Sorry, let me. This is TR over L is equal to mv squared over r. Okay. So now move everything to the other side. You get T is equal to mv squared L over r squared. I definitely do applied math, yeah. They still want to keep the sine squared theta in there, though. Man. Why can't I just write it this way? Technically, it works. It's technically good, dog. Dun, 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 dun. Applied math? Applied math is like math with more formal applications. Like more useful applications. Bruh, why do they want the sine theta in there again? I don't want to do it. mv squared over L sine theta. Well, okay, wait. From this, right, I get that T is equal to mv squared over R sine theta? And is there a relationship that tells me that R sine theta is equal to L sine squared theta? Because I don't need G in there. T sine theta equals mv squared over R Cool. So mv squared over r sine theta is equal to... Oh, that's equal to t. No. That's equal to... No, that is t. That is t. Wait, so why is this one right? They want us to get rid of r. Oh, okay. Fine, fuck. That's really dumb. I don't know why they're doing this to you. But okay, here, watch. If this is r and this is L, then sine of theta is equal to r over L. So r is equal to L sine theta. Oh, okay. And now this goes back into here. So now you get t is equal to mv squared over L sine squared theta. Aha. Okay, cool. Nice. All right, and that's why it's that. That's kind of silly. I feel like they were just trying to like... I mean, looking at the question, I guess you understand that I can't have anything in terms of R or G. So I need to replace those with other values. And that's what we did. We just drew a triangle. Very cool. Okay, cool. Nice. Good question. That was Eric.
Well done.
So let me download this. Nice. And then let's mark it. Okay. And then... What's up, Lineatrix? Okay. The next couple are kind of people submitting multiple ones. So here, Z Sigmund, are you still here in my chat, Z Sigmund? I'll do yours real quick because this one doesn't look too bad, and I know you've been waiting, and you're active. Just chilling on the bus, nice. Yes, okay, Z Sigmund, here, it's your lucky day, because I feel like I want to do something other than physics right now. Okay, the roots of the equation are alpha and beta. Find all quadratic roots with roots alpha, beta, and a plus b. Oh, okay. All right, well, no. So here's how you do this, right? So if you have x squared minus 4x minus 11 is equal to 0, you need numbers a and b. So a times b must be equal to 11. Right? These two numbers have to multiply to negative 11. You can always submit a screenshot, Thopter. You know what's up, Free Fire. And then you need them to add up to this. So then I need a plus b to equal to negative 4. Oh, okay. So ab equals negative 11. A plus b is equal to negative 4. Interesting. Okay. Well, if I'm just going off kind of a guess here, Sigmund. Yeah, you see this? You see this? Okay. I'm gonna go off a guess here. Like, if I square this is also squared. Use gold rule for factoring.
Oh no.
Actually, you could actually. But let's try to do it this way. I think this works out. So a plus b squared would be equal to negative 4 squared, which is equal to 16. Okay. But a plus b squared is also equal to a squared plus 2ab plus b squared, which is equal to 16. Right, if I factor this out, if I expand it. And then ab is also equal to negative 11. So now I have a squared plus 2 times negative 11 plus b squared equals 16. So then a squared plus b squared is equal to, what's that? So that's negative 22 plus that is 38. Does this help us out? I feel like we're getting a little closer at least. So I have a plus b is negative 4. A squared plus b squared is equal to 38. Find all quadratic equations. Oh. Wait, what? Yeah, we don't know a or b. Well, here's the interesting thing. Okay, if the roots are this... Okay, watch this. Okay. if roots equal x1 and x2, the factors are x minus x1 times x minus x2. Maybe I'll take a look at it. If it's something quick, maybe. Okay, does this make sense, right? If these are the roots, these are the factors. So if AB is a root and A plus B is also a root, you have x minus AB times x minus, and then this is A plus B. Okay? So now I think you just foil this shit, right? So let's just do it. Okay. So, yeah, does it make sense? Yeah, thanks, dude. I need help, BH. I need help, too. So this is x squared, and then it's going to be plus AB times A plus B. Right, so first, whatever, like these two, and then I'm going to do this. Sorry, I'm going to do this times this. So minus x A plus B. And then this one plus x AB. Exactly. Yep. So say x1 is equal to AB. X2 is equal to A plus B. I don't even think we need two lineatrix, because watch. Once I've gotten to here, right? And now I foiled it out. Let me make sure I foiled this right. Yeah, cool. No. We fucked up one. No, that's okay. XAV. Now watch this. This is really cool. We already know what AB and A plus B are, right? AB was equal to negative 11, right? And A plus B was equal to negative 4. So now you have x squared plus negative 11 times negative 4. I think that's right? That's what we're doing? Yeah, 8. Yeah, good. This is really fun, actually. Okay, minus A plus B, so that's plus 4x, and then minus 11x. Oh, fucking dope, dude. And sorry, this is all equal to 0, right? If these are factors, this is also equal to 0, right? This is equal to 0. Yeah, if it comes, submit a screenshot of it, Ethan, I'll do it. So this is x squared, 4x and minus 11x is minus 7x, and then this is plus 44. Yeah. Okay, so then this is it. This is the quadratic equation. Find all quadratic equations. Okay, so it's this times A. That website, actualofficehours.com. Okay, very cool. Very cool. Cool question, Sigmund. Yeah, because any multiple of that also works out. Right? So it's just n, and then you can say, like, for all n. Because they said find all the quadratic equations. So this is the base quadratic equation, and then if you multiplied it by, like, let's say, like, 2, or, like, 3, or, like, 67, it's still gonna have the same roots, because whatever this number is here, you can just divide it out to get rid of it. Yeah, that's a cool solution, actually. I like that one. Very cool, Sigmund. Thanks for asking that. Sigmund with question 11. Okay, let's mark question 11 over. Yeah, it kind of makes sense, right? Nice. Okay, I'm going to put this in our Discord so that you can have the solution later. Just make sure, go join our Discord on the same link you used to submit the screenshot. And then you'll see the downloadable image file for what the solution was. Bro, I was trying to learn alpha and beta for 2 hours and I couldn't get it, but I do now. Dope, dude. Yeah, if things don't make sense, yeah, come by. We'll help you out. Okay, I've already answered Eric's and Jason. I've answered questions from these people already, so I'm gonna go ahead and, if I have time, I'll go back to doing multiple questions, but I want to make sure I do at least one question from each person. Yeah. W. Sigmund. Yeah, glad, dude. I'm glad this stream helped you out. Right. All right, this one, bro, mine is the easiest. All right, one sec. I'll check yours real quick. Free fire. No, not the easiest. No, I still have to read too much. If it was literally like 1 = 2, then yes. No, it takes a little bit of time. Free fire. What a long name you got. Yeah, dude has a long name. Okay. Okay. Oh dear. Okay, I'm gonna do part of this. Because for delta H, this is another limiting reactance question. Yeah, this is... Did you say 1 = 2? Yes, I'm Terrence. So, limiting reactance, because you need to do delta Q over N. And you have to use limiting reactance to figure out N. We did that yesterday. I'm not going to spend all the time doing that as well. But I will at least figure out Q for you. Okay, right? So the coffee cup calorimeter, so Q is equal to MC delta T. In this case, your mass of... And wait, they don't have... Right, they don't have the coffee cup calorimeter doesn't actually have a specific heat, which is nice. So if you add 50 milliliters with 25 milliliters, you get 75 milliliters of water. But then the key thing here is that 1 milliliter is equal to 1 gram. That's what the density says. So this is going to be 75 grams. C for water is 4.186. Just sneak your phone. No, don't do it.
Surprise, motherfucker.
And then delta T is equal to 27.21 minus minus the 25 it started at. Nice. This is chem. Okay, cool. So that ends up being 75 times 4.186 times 27.21 minus 25. And I think Q is negative because it's exothermic at this point, right? Okay. So that's equals to 694. Nice. So this is equal to 694 joules. Cool. That's equal to Q. If you want to figure out delta N, you got to go do limiting reactants. And then the reaction for this, right, is that you have HCl plus NaOH is bonding to form NaCl, which is salt, plus H2O. And so you have to figure out how much of this gets made. Oh, which actually you can already you can already see with limiting reactants actually here. This is actually kind of cool because everything is 1, right? Oh, this is actually really dope. Actually, I can do this next part really easily. Okay, wait. So, I can definitely do, yeah, improper integrals, yeah. The channel is called Homework Help, Sigmund. It's down at the bottom. Okay, so, dude, what is going on with my pen, dude? What the fuck? No. Oh, let me get rid of the calculator. Okay, moles HCl. That's equal to 0.05 milliliters times 0.5 molar. So that's equal to 0.025 moles. And then the moles of NaOH. Wait, sorry, that was NaOH, sorry. I fucked this up. And then this is HCl. HCl is 25 times 0.5. Okay, cool.
Good job.
So you already know this is limiting. Nice. Is that you? Oh, Sigmund, did you find it? Is that your... Good. You know you get points in my server for asking questions. So, there you go. There's your first bond coin. So this is going to be 0.0125 moles. Okay, very cool. This is limiting. Because everything is 1-to-1. So you're going to run out of HCl before you run out of NaOH. So then delta H, right, is going to be equal to Q over delta N. But the number of delta Q over N. Delta Q over N, or whatever. Well, Q is technically a delta. It's not a state function. Whatever. It's 694 over 0.0125. Oh, well, we don't scam people. Free Fire. Yeah, we're not scammers. Don't worry. Sounds like something a scammer would say, though, right?
That's dope.
Okay. So, 694 over 0.0125 is 5552. So that's equal to 55.52 kilojoules per mole. Nice. Very good. That's a fun question. You're very welcome, Z Sigmund. Yeah, have a good night, dude. Thanks for coming by.
Well done.
Oh, yeah. Well, we do a pretty good job of getting rid of the scammers in our Discord. I have a pretty dope moderation team. All right. That was Bing Bong.
Bing bong.
Okay, so Bing Bong's question. Yes, okay. There technically is a queue, but because you've been asking a lot, I will give in and I'll do it. Just to... You said it's fast, so we'll see. Wait, Free Fire? This yours? Coming up. Thanks, Eric. Who's Eric? I'm not Eric. Or is that Unk? Did you mean to say thanks, Unk? Yeah, it's just literally for the Bing Bong guy. Yeah, I added that sound effect just for Bing Bong.
Bing bong.
Also, I love it. Okay, f of x is defined as ax squared plus bx plus c, where a, b, and c are constants. If f of x is in the xy plane and passes through the points 7, 0, and negative 3, 0, if a is greater than 1, which of the following could be a value of a plus b? I don't know if this is necessarily easy, but sure, we'll check it out. So 7, 0, right? Oh, okay. Actually, I do know how this works. And then negative 3, 0. Yes, Minitut, well, be nice. Submit a screenshot. So someone literally just did a, this was an enthalpy question for chemistry we just did. So if you submit a screenshot using the website down below, I'll get to it. Okay, here's the cool thing about quadratics, okay? So first of all, they say a is greater than 1, so that means it must be a happy face. Remember, if the leading coefficient, so ax squared plus bx plus c, if this is positive or greater than 1, that means it's a happy face. If it was less than 1, it'd be a sad face. Okay? So, that means my graph looks something like this, right? And then here's kind of the cool thing. This is really cool, actually. With any quadratic, the vertex here, the x coordinate is equal to the midpoint of the zeros. You're good, Tom Blues. Yeah, I'll probably get to it. Some people have asked double questions, so I'm skipping theirs until I answer one from everyone else's, and then so since you haven't asked a question yet, I'll get to yours sooner. Does this make sense, by the way? Free Fire, right? That the vertex here has to be the midpoint between the two zeros, okay? And so the midpoint is just the average, right? Okay, so that's negative 3 plus 7 over 2. So that's equal to 4 over 2. So that's equal to 2. Okay, so the x-coordinate of the vertex So x coordinate over the vertex is equal to 2. And then this is something we learned also previously as a little shortcut. This is also equal to negative b over 2a. Okay? So now I know that negative b over 2a is equal to 2. Alright? So then what could be a value of a plus b? Interesting. So negative b is equal to 4a. Okay, this is really cool, actually. So a plus b, right, equals what? Oh, but b is equal to negative 4a, right, from this? So if I plug that in, I get a minus 4a is equal to what? And so that's negative 3a is equal to what? Okay? And then here's the cool thing. They said a is greater than 1. So it has to be greater. So if a is greater than 1, this has to be more negative than just negative 3. And that's why the answer is negative 6. How negative b over 2a? This is something you just memorize. This is a trick. Yeah. You just have to know that. It's a trick for parabolas. There's a derivation somewhere. But here you go. This is it. It's the axis of symmetry formula. Yep. DM Scrader's right. That's another thing. That's actually a really cool question. Yeah, so that comes from this. And then, yeah. And then you're done. Yeah, so answer is negative 6. Right? Because a must be greater than 1. So, this has to be less than negative 3. So, equals negative 6 is good. Nice. Cool. All right, great. Good question. I tried a systems of equations setting f prime of 2 equal to 0. No. You don't need to do that. Don't need to do that. Don't need to do that. The problem there is that would be ax plus b. And you don't have a coordinate. I mean, I guess you have the vertex maybe, but nice. Free fire. Good. What question was that? You were number 12 in the queue? Okay, so it's post number 12. Yeah, unfortunately, sometimes there are things you have to just have memorized in order to solve, and I would say that negative b over 2a, someone brought it up earlier, it is a good trick to know. Okay. Let's see what we got coming up next. Midget Mucker. What's up, Midget Mucker? Is that still like a legal name? Oh god, dude, this is a mess. Okay, I'm not gonna do the whole curve sketching, Midget, because this just takes forever. I'll do some of it. Yes. Correct. Okay. There's its derivative. There's its second derivative. Great. Domain. Okay. So here. I think technically you have to factor this, dude. That's kind of a mess. Ugh. Doesn't really factor nicely, does it? Yeah, it doesn't. Right? 2 and 46. 18 and 30. No, it doesn't factor. It is nice they give us the derivatives. You're right. So the domain. Okay. The domain is all x except where the denominator is equal to 0. So basically, you just set 3x squared minus 6x minus 9 equal to 0. That's the denominator. You can factor out a 3. So x squared minus 2x minus 3 equal to 0. So that's going to be x minus 3, x plus 1 equal to 0. So the domain is going to be from negative infinity to negative 1 union negative 1 to 3 union 3 to infinity. That already tells you also where the vertical asymptotes are. Technically, you got to make sure they don't also cause this thing to be 0, but I assume they're not. We love dividing equations. Yeah, Burrito. I mean, I could divide this. Yeah, you are right that this is a slant asymptote. So okay, so it technically doesn't have any horizontal asymptotes, right? Because slant asymptotes aren't horizontal asymptotes, even though I feel like they kind of are, but they're not. But this has vertical asymptotes at x equals 3 and x equals negative 1. Dun, 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 dun. Intercepts. Oh, that's ugly. Because, yeah, this doesn't factor very well, does it? Okay. But, here, critical points is where f prime of x is equal to 0. So x squared plus 2x minus 11 is equal to 0. That's also not very nice. Right? Dude, what? Nothing really factors nicely there. Dude, this sucks. Every polynomial is factorable of the complex numbers. You're not wrong, Zach. Okay, whatever. That gets you the critical points, and then you got to test in between. And then just make some graphs. This is absolutely horrendous. No, don't worry about dude. Scammers who say they're gonna leak videos about you, dude. That's the oldest trick in the book, dude. No, those aren't real. One sec. I want to just get the graph of this. You should do more linear algebra. Well, ask me more linear algebra questions and I'll do them. Yeah. I say, yeah, if you want me to do more types of like a certain type of question, just submit more questions that look like it. No, I don't need it factored. God damn it, ChatGPT, just give me the text. I just don't want to type it out. Yeah, I think you're good, dude. I think you're good. Yeah, it's not. Yeah, just give me the rational expression for Desmos, chat. That's all I need. Oh, x minus 3 did get canceled. No, I don't think it did. Oh, it did. Oh, shit. I still don't think you can have it in the domain, though, right? What's up, Mathematic Fanatic?
Bing, bing, bang.
Okay. Here, I was just gonna graph this. There we go. Cool. Oh, so it doesn't have a vertical asymptote. All right, well, I screwed this up. There we go. That's what I wanted. Okay. So interesting. Ah, the x equals 3 actually gets canceled. Man, I wouldn't have done that. I didn't think that 3 worked on this. Oh, man. Okay, so there is no vertical asymptote at 3. So, I apologize. So this is union 3 to infinity. Or, sorry, union negative 1. infinity. Yeah, okay, cool. Then you can say, here, but x minus 3 gets canceled. Cancelled on top. How long is the queue? We're up to 11. And I have 16 minutes left. So lots of fun questions for you, Zach, later if you want to solve them on your stream. Maybe Saturday. If you're looking for things to do. Again, don't ever feel like you're pressured at all to do these. I'm just collecting information. I'm just collecting content. All right, cool. So this is x equals to -1. This is the slant asymptote that happens, right? So I don't think there's any... So no horizontal asymptotes. But then there are going to be critical points, like, I guess here? Right here and here are critical points, which are ugly. He's feeding the math into AI to help the uprising. Yeah, I am working on vibe coding something to use all my Microsoft credits to just blast this thing. Blast these questions through, like, GPT-5 Pro. Okay, cool. All right. I feel like this is good. I want to make sure I get to everyone else's questions. But for now, Midget, this is a good start. Midge.
Well done.
All right, that was 4.
Done.
Okay, Midget Mucker. Yes, we all think you're safe, Free Fire, dude. Don't worry, dude. There's a lot of trolls on the internet. Alright, let's leave that. We've gone through a lot of things today. Alright, where was Thomas Blue? Tom, this is yours, right? The heat exchanger, I think? Because here, Eric's already asked, Jason's already asked. There he is, okay. Volume flow rate, ooh. Yeah, what the hell's going on here? Alright. No, dude, the journey is the friends we made along the way. Okay. And there's a heat exchanger at 4 bar. A quality... Dude, this is all engineering. Oh, man. I don't know how to do this one, Tom. Because I'm guessing this is like a specific engineering thermo class. Because, like, what is this value, quality... This value, like, quality in physics, like, doesn't exist. Yeah. Okay. I'll be honest with you, Tom. I don't know how to do this because I don't know what, like, quality means. I kind of know what CP and CV are. So, let me run this through chat for you. And I'll post the link for it. So you at least have, like, a paid version of ChatGPT that solves it. And then, yeah, I'll tag my engineering majors in my Discord if someone wants to explain it. But again, use the AI as kind of as a friend to see how they do it and see if it makes sense, like the steps they're taking. I don't know what quality means. It's an intensive prop you can work with, yeah. So, I mean, the way I would want to do it is PV equals NRT. That's what I want to do. But then, how does volume flow rate refer to that? Or does that have to do with, like, heat flux? Here, I'm curious myself just to see how chat solves it. Just because I'm going to teach myself some engineering fluid thermodynamics at this point. Yes, okay, and then we're talking about, like, superheated states. So this is where you have to use these weird tables. This will take years? I don't know. I think it's going to do it right now. Let's just see. It's pretty close. I agree, like, you need an energy balance at some point. Okay, cool. And then you do, like, the air heat loss. Okay. This is always very cool because it tells me, like, how it's doing it. Which can be, this is useful to learning, to just see, like, how other people do things. This is why, even before AI came out, a big way I used to learn in my college classes were from, like, solutions manuals. I would just look at the solutions manuals of what other questions have been done, and that taught me the pattern on how to do it. Yeah, this is very good for learning, right? Okay, so here, yeah. I mean, if you're just blanket copying shit, then you know. You're not going to learn. But this is kind of cool. So this is ideal gas law, right? PV equals nRT. But then they're instead of n, they're saying n dot. So it's like it's a derivative. Where like V is a volume dot. Okay, so that's a volume flux. Oh, cool. So then Q dot is equal to M dot C delta T. This is cool. I see where these are based in. These equations are based in like what standard thermo is, right? We know PV equals nRT. We know Q equals MCAT. And then this is the energy balance. Wow. Yeah, mass flow rate, volumetric flow rate. Yeah, exactly. No, it's cool. It's just derivatives of standard thermo. Okay, cool. All right. I'm going to post a link to that for you, just so you can see it. Tom, are you in my Discord? Question number 4. Oh, if it wants to load. ChatGPT has been lagging recently with me getting like links to things. I just want the link to this, please. Just join. Nice. Okay, yeah. So in the homework help forum channel, you should see your question, and once this link pops up, I'm gonna dump the link for you, so that you can kind of like follow along and see if it makes sense to you. And yeah, you do need tables, I guess, for this one technically. Yeah, you're very welcome. I just need a link. Come on, ChatGPT. All right, there you go. All right, cool. Got a link. I'm gonna copy that link in, and so you should see it in there, Tom. There's a link there, so you can also follow along. Zach, were you here when I was talking about my next vibe code project I'm doing? My next project for vibe coding? I come up with these fun... I feel like we both like to come up with little programs to help our streams out, but you're more rigorous about it, and you want to do it the right way. I just want to get it done. Just like, how do I get this done as quickly as possible? Wow, Zach, what's this? What's this, dude? Yeah. So Zach, what I'm gonna do is I have like $2,000 worth of like Microsoft credits that they give our nonprofit per year. And Microsoft, right, owns a significant stake in ChatGPT. So I have basically $2,000 in API calls for ChatGPT. I want to create a bot such that if a question that we don't get to during the stream gets put into this Discord and it remains unsolved for like 2 days, that the bot that I create, this Discord bot, will use the highest version of ChatGPT, which is ChatGPT 5 Pro, which you can't get unless you have a $200 subscription. But I have API credits that I can call it. And I'm just going to run it through it as kind of like a backup and just tell the students like, hey, you know, fair warning, this is AI, but, you know, rather than you spending $200 a month or even $20 a month to get an AI solution to look at, we're going to give it to you for free. You want to know what ChatGPT has to say about this series? Okay, sure. Let's do it. I'll throw it in the background. Dude, thanks, Tom's Blue. Thanks for the galaxy. Wow, that's sick, dude. Appreciate that. A galaxy, that's 1,000. Dude, wow, that's nuts, dude. Thank you, dude. Here, I'm going to send this just for Zach. Here, we'll say solve. See what it says. I'm going to let it munch on it a little bit. I might pull an all-nighter to do some programming. Nice, Famished. Yeah, I was working on some programming today. I kind of ran out of time. What does Tiamat got? Draw a full section for the ribbed flange? What is this? I don't know how to read this. Oh, thank you, Tom. I appreciate you, dude. Yeah, rapid. So that's the goal, DMs. Is that at the end when I don't have time to try to at least help you guys by using some of the money Microsoft gives us to put it to good use. Young's modulus. Yeah, again, I don't know Young's modulus. That's engineering. Sorry, Drew. DMs, I answered one of your questions already today. Speedy. Ooh. I feel like I could almost do this one. Let me, I want to separate one of these real quick. One sec. Why is it doing that? I have 4 more chapters in my, yeah, okay. Just, yeah, get through it, famished. Okay, I'm going to do speedies real quick. What's up, Justin?
I forgot I could just let myself up.
No, you're not a full mod yet. I gave you trial mod. Like, you don't get instant mod promotions, like, immediately, right?
It says request to speak will show up here, and it allowed me to join the stage.
Oh, okay, cool. Then maybe you do have full mod permissions. I forget. Whatever. Welcome. DM's creator. I always answered one of your questions right. No. If I had time DMs, I would do it. I just want to make sure I do at least one question from everyone first. All right. R is a region. X is between 1 and 4. Love that. Let's do it. So we're gonna say from 1 all the way out to 4, and then Y goes from -2 to 3. Oh, it's not even complicated. Oh, this is beautiful, actually. Actually, not really hard at all. So -2. What's up?
Is that less than equals 2?
Yeah, this is less than or equal to. Yeah. So it's just a box. It's a box.
Yeah, it looks like just one big ass box.
Oh, okay. Oh, this is actually not bad. Okay. So then this is the integral, and dA in Cartesian is equal to dx dy. So outside y goes from -2 to 3, and then inside dx goes from 1 to 4, and then it's x squared minus 2xy squared plus y cubed dx dy. What's up, 74? I'm not sure if you remember me, but I used to post calculus problems, and I'm from Egypt. I stayed up to 3 a.m. Hey, you helped me pass. Aw. Appreciate that, 74. Peak, dude. Thanks, man. I'm glad you passed. That's dope.
That's dope.
I hope to visit Egypt at one point. I haven't really been to the Middle East. I'm waiting for it to like kind of like chill out, honestly. Okay, none of this is actually really that bad. This maybe would have been bad. This is Fubini's theorem, by the way. Isn't this Fubini's? Visit India? I do want to visit India. It's on my list for sure. Because I've heard India is just chaos, and I fucking love chaos. Yeah, this is Fubini's theorem. So this is, here, real quick, this is Fubini. Such a funny guy's name, Fubini. Which basically means, like, you can separate the integrals into what their variables are. So since this part only has the y's in it, you can do -1 to 1, sine of y, and then integral of 0 to 2, e to the cosine of x, dx, right? And then dy. Aha. Okay. But this is kind of a pain in the ass to do. So I think what you do is you flip the order, right? Visit the good places. What if I want the bad places? I think you do this. I think you do e the cosine of x. I'll do the second, this last one, because I feel like this is easy. You just, do this. It's just mechanical. This is actually kind of tricky. And then this is sine y from -1 to 1, and then this is dy dx. I believe, yeah, because there's no funny variables going on in the bounds. Bad places equals street food. What if I want the street food?
That's dope.
Okay. Okay, this is cool. Integral of sine y is negative cosine y. All right, so we got 0 to 2, e cosine x. And then it's negative cosine of y, evaluated from -1 to 1, dx. I've been to Korea. Yeah, no, I love Seoul. One of my favorite cities I've ever been to. I absolutely love Seoul. Big fan of the odang. Big fan of the... What's that? Gochujang? Kamsamnida. And then what is this? This is negative cosine of 1 plus cosine of -1 dx. Oh, wait a minute. Isn't cosine cosine's an even function, right? So cosine of -1 is the same thing as cosine of 1, right? So this is just fucking 0. This part is 0. Because cosine of -1 equals cosine of 1. Beautiful. Okay, so then the whole answer is 0. Nice. That's a really cool one. But you wouldn't have seen that, right? Unless you separated the integrals out. I usually feel pretty good at math. I'm glad this channel reminds me how much more there is to learn. Dude, learning is infinite, dude. I'm 35, almost 36. I have a PhD in physics, and I still learn something every single day on this stream. Someone gives me some question that I've never seen before, and I learn something about it. It's really cool. Yeah, who was this? This was this Speedy? This was Speedy. Thanks, Speedy. That's a fun question. Where's my panel? No, not there. Go away, go away, go away. All right, let's see if the convergence figured itself out. All right, that was 7. Post 7. Delete 7. 38 with 2 master's degrees, and yeah, there's always more to learn. Yeah, 100%, dude. I 100% agree, Todd. And honestly, that's the beauty of the internet, is knowledge is just infinite. There's so much stuff out there. There's a lot of garbage. Like, don't get me wrong, there's a lot of trash out there, but there's so much good stuff as well that you could just learn forever on the internet. You used to have to, like, go to a library. Like, I don't want to go to a library. I don't have to go, like, I can only check out one book at a time or something. Being considered that smart kid can make you, yes. There's always more. Never get to, okay, ooh, we're out of time. Okay, cool, I gotta end that stream. All right. Thank you, everyone, for coming in to Actual Education Office Hours today. Appreciate all the questions. Again, if we didn't get to your question, do not worry. It will still get submitted to our Discord, so I highly recommend, if you're just watching us now, or if you've been watching for a bit and we didn't get to your question, go to this website, actualofficehours.com. That's where people have been submitting screenshots for questions. You can click here on Join Our Discord, and that will join our Discord community, where you can see your question being posted, and then I have an awesome team of other friends who love to just donate their time and help out, and so they may answer your question for you. If you're looking to also, if you're just kind of bored and want to help out, please feel free to join our Discord, sign up as an educator, and you are more than welcome to help out with all the other questions we get on the stream. Also, yeah, make sure check out the streaming schedule here, which tells you all the times that we stream and all the times our friends stream. So our next stream will be tomorrow at 4 o'clock Pacific time. I'm actually extending that stream to be 10 hours long. So we'll be streaming for a very long time tomorrow night to celebrate 10,000 subs on YouTube. So come by Thursday night for some fun. Friday, Zach and Penn Center will be having a podcast stream where they're going to talk about math, education, funny dad jokes. Make sure you come by on Friday. That's going to be dope. And then on Saturday, Zach has another help stream. So check that calendar. It'll tell you when all the stuff is going on. Yeah, the 24-hour stream I'm building up to. I want to see if we can do 10 first, just to make sure all my computer stuff works. Yeah, awesome. Yes, good. Double integral is surface area. All right, let's go to can dad jokes be funny? Are they dads? Yeah, Zach is a dad for sure. I don't know if Penn's a dad. Penn's probably a dog dad, but if you're watching us on Twitch, we're gonna go raid one of our friends. Oh, I love this. Ask a Science Gaming. These guys are awesome. So this is kind of a fun little interview podcast thing where this guy at University of Florida brings another scientist on, and they play video games and answer questions. And it looks like this guy's talking about grad school applications. So cool. If you're considering going to grad school, go ask Dr. Ken Hansen on this stream about that. He'd be happy to help you out. Yeah, okay, nice, Zach. Yeah, we salute you. Okay, cool. All right, thank you, everyone, for coming by. We will see you tomorrow. Enjoy your Wednesday. Peace.
is yes. I don't know. It's fun thinking about the actual topics rather than plug and chug nonsense. Woo! Speed strat. That was really good. 5 seconds behind 9:07 time. Actual Education, thank you for the raid. Thank you for joining us. You guys should check out Actual Education, science and math tutoring while on stream, which is pretty amazing. Chem 2 is better than Chem 1, but Actual Education, how was your stream? How was your night? Hopefully you're having a good time. We're flipping the script a little bit tonight. I'm the guest for this evening, and Eugene DePrince, a colleague in my Department of Chemistry and Biochemistry, is hosting. We're talking about graduate school, graduate education, graduate admissions. So yeah. Grad Cafe, I don't know what that is. Oh my god, that was bad. That's fine. I don't know what Grad Cafe is. If you have insights, I've never heard that. Is that like collaborative application? Oh, forum for all grad students to track admissions. Man, that's
Like when admission.
yeah. It's like, oh, I got admitted to this program. I know that exists for professor positions on like ChemJobber, but man, I don't know if that's good for students to keep track of that because they're just losing sleep while they try to. Man, that's crazy. But yeah, so I'm chair of the Graduate Recruiting and Admissions Committee.